Hello out there, everybody. Thank you so much for joining us. We're just gonna, kibitz a little bit like we do to start out the show. Welcome and thank you for joining us. As always, please let us know where you're coming from in the chat, wherever you're watching, whether it's on Zoom, YouTube, Twitch, Twitter, LinkedIn, etc., etc. We love seeing where the global OpenCV community is watching us from whenever we do these shows. Obviously today we're doing a little bit different of a thing. It's Wednesday, not Thursday. I don't know if you noticed. It took me a minute to remember this morning, but here as always is our host and the CEO of OpenCV Live. Satya, how you doing today?
Doing great. Joining from San Diego, and I love seeing how people from all around the world come to our webinars. And this show is very, very special because today we just launched our Kickstarter, our Indiegogo campaign for OpenCV 5. And as you know, the launch of OpenCV 5 has been delayed for some time. And we decided that, okay, let's try this experiment, right? OpenCV has been traditionally funded by large corporations, and we have never directly asked for funding for the library from the community, right? And I really wanted to see how the community would respond if we did an Indiegogo campaign. And the reason is that over the last 1 year or so, right, or maybe a couple of years, we are seeing this trend that open source is gradually, some of the largest open source initiatives, for example, OpenAI, they turned into closed source, right? ChatGPT is no longer open source. And they also turned into a commercial license, right? So you have to pay, which is understandable, right? Because they have to maintain, they have to do the research, etc. But this trend,
and when they drive a dump truck full of money to your house, it's hard to say no, you know?
Right. But there's also, I mean, I cannot blame them because it's a double-edged sword, right? Open source and free is a double-edged sword. If you can maintain it, if you can do the research and development, supported by the community and corporations, then it's a great model, right? And it is the right model for code that is infrastructure level, right? Like OpenCV, I feel, is a code that is forms the foundation of most computer vision applications, right? So code like this should be open source, it should be free, so that people around the world can use it. But I can also see why OpenAI went the route it went, right? It is very difficult to fund open source, right? People love using, every time we hear we love OpenCV, if I get, a cent for it, then OpenCV would solve all its funding problems, right? Immediately. It's downloaded about 2 million.
If we had a nickel for every PhD that heavily used OpenCV, we'd have, as they say, a shit ton of nickels. I think let's get started proper. You ready over there? All right, we've got some special guests here today to play the OpenCV Live theme. Ladies, gentlemen, theys and thems, the Mayflies. Satya?
Thank you. I mean, that was great. I mean, we should do this more often. The Mayflies.
I know. Why can't we have this all the time? Yeah.
Right.
So Satya, let's get started. Tell the people who you are and why we're here.
Well, I'm the CEO of OpenCV.org. OpenCV.org is a nonprofit that maintains the OpenCV library. And as people know, many people know that OpenCV is the biggest computer vision library in the world. It is downloaded about 2 million times a week, and that's just the Python version. If you take the C++ version, for which we do not have the numbers, I think it will be double the number, right? So 4 million or so times a week, right? Now, today we are here to launch OpenCV 5, the campaign for OpenCV 5. This is very important to us because this is the first time we are doing a crowdfunding campaign for the OpenCV library, right? And we know that OpenCV 5 has been delayed because of several issues. COVID hit, and then we had some funding issues, etc. But now we are reaching out to the community, and we hope that this campaign will raise $500,000 with the help of all the generous supporters, and we will be able to launch OpenCV 5 in about, the first version we may be able to launch 6 months or so after we get the funding. And there will be improvements, subsequent versions, minor versions that will come out over the year. But the first version,
we know that it's not a small ask. $500,000 is actually a pretty risky raise to try to get in crowdfunding, especially for an open source project. I don't know of too many that have done this outside of our friends at the Linux Foundation, possibly. We know we're asking for a lot, but we're asking for a lot because OpenCV is worth a lot.
Right. But another way of looking at it is that, if you look at entry-level positions in AI today, right, if you do a Google search, then the cost of one AI engineer, right, it is $120K. That is for an entry-level AI engineer in the United States.
That's not even San Francisco prices.
Oh, no, not San Francisco prices. So $500,000 doesn't buy much. And one of the things that we are guaranteeing during this crowdfunding is that every penny is going to the development of the library. Even now, about 90% or maybe 95% of our total expense goes towards development of the library, right? None of the management, we don't take even a dime, as Phil, but Phil likes to mention that, technically I get paid $1 per year, the CEO salary of $1 per year. But Gary has not sent me the check for the last
That's
2
right. With
years.
interest, I think he probably owes you about, 205, something like that.
Yeah, and with inflation adjustment, we should do. So so what we are asking you, Phil has already shared. I think Phil has shared the link to the project.
Sure did.
Please donate generously, right? And the kind of donation, I'm not going to be shy to ask because I'm asking for the community. The kind of thing that we want is, if you're a student, right, donate $21, right? Especially in the United States, that's like, you went out for lunch or something, that's $21, right? To support your favorite library, it makes perfect sense to donate that amount. But if you are a working professional and if you have used OpenCV in the past or you are using OpenCV on a regular basis, think about a few $100s, right? And if you are, a high net worth individual, right, then I am asking you to donate about $5,000. Now, this may seem like a lot, but if you think about how much OpenCV has contributed to your career, right, now that you're a high net worth individual, it only makes sense to give it back to the community, right? And my career has, I have used it, OpenCV during grad school. I have used OpenCV throughout my first company that I made. And even with my current consulting company, I use OpenCV extensively, right?
So Satya, can I ask you, are you going to donate?
100%. I'm going to donate $5,000, right? And I'm trying to get some of my friends to donate $5,000 as well. And we'll do it live, all right? So that once we have some guests and you're engaging the guests, I'll go and donate the $5,000.
Sounds awesome. Speaking of guests, we are going to get one more song this morning from the house band, the Mayflies. Thanks so much for joining us, folks. After this, we will be talking with Jeff Powers, an old friend of mine from Arcturus. But one more time, the Mayflies.
Fall is here, I hear the yell, back to school. by the tree. We will rest upon the ground and look at all the bugs we've found. Safely walk to school without a sound. We safely walk to school without a sound. Here we are, no one else. We walk to school all by ourselves. The grass stains on our uniforms from chasing all the ants and worms. We clean up and now it's time to learn. We clean up and now it's time to learn. Numbers, letters, and learn to spell. Nouns and books and show and tell. Playtime we will throw the ball back to class through the hall. Teacher marks our height against the wall. The teacher marks our height against the wall. We don't notice any time pass. We don't notice anything. We sit side by side in every class. Teacher thinks that I sound funny, but she loves the way you sing. Tonight I'll dream while I'm in bed. When silly thoughts go through my head about the bugs in the alphabet. When I wake tomorrow, I'll bet that you and I will walk together again. Yes, I can tell that we are gonna be friends. Yes, I can tell that we are gonna be friends. No problem.
That was the Mayflies.
You're muted.
Sorry about that, folks. I was muted. That was the Mayflies, Henry and Jess Nelson. Folks, do y'all have any upcoming gigs you want to promote while you're here?
Well, I have a gig on November. Whoa, am I good?
You're good. Go for it.
I have a gig on November 22nd at Iron Shoe Distillery, downtown Niles, from 6 to 8 p.m. So
All right.
hope to maybe see you there.
Yeah, if you're in the Michiana area, come check them out, the Iron Shoe Distillery. Yeah,
It made the contribution.
you did it? All right.
I did. Should
Excellent.
show up. At least it's showing up.
I'm looking. We're sitting on 33 backers right now. We launched about, oh gosh, maybe 2 hours ago, something like that. So people are just waking up on the West Coast. Yes. So coming up here in a moment, we should have Jeff Powers from Arcturus joining us. But before then, I'd like to thank all 33 of you that have so far donated. We've got quite a few people taking the $21 tier, and some people taking the step up tier. We've got one Save Icon supporter and a few Prime philanthropists, as we were saying in there. I think what we're going to do now is play the campaign launch video, as we see my brother Chuck's head bob in and out of frame while he attempts to fix camera 2. Steve Simpson. Yeah, you know what, Steve? Later in the show, absolutely. So yes, I'm going to go ahead and share the screen here. A little bit slower than usual this week. Should be able to pop in here.
There was a question about, what are the new things coming in OpenCV 5, and we'll go over that as well whenever we get a chance.
Absolutely. Let me share this video. Zoom is being uncooperative. Why is this not working? Optimize for video. Sorry, folks. Wouldn't be an OpenCV show if something didn't go just a little bit wrong. So, Satya, did you take the kids trick-or-treating?
I did, and I ate all their, I would take a bullet for my kids. So, and sugar is poison, so I ate all their candies as well. Yeah, just to save.
Wow, that's a good one. That's a Satya right there. So yeah, I'm gonna go ahead and share the campaign video here. Let me know when you can see that.
Thank you, Tony. I really appreciate it. I just saw.
All right, I'm gonna hit play on the campaign video here. OpenCV is used everywhere. In outer space on rovers, and on terra firma in emergency rooms, on farms and on campuses. It's in your laptop and your social media apps. If you're using a camera on a computer, odds are you're using OpenCV.
I don't think I can name the very first time that I used OpenCV, and I think that's probably a reflection of how embedded it is for all parts of image processing in general. It's just a natural part of the workflow.
Over the last 20 years, the Open Computer Vision Library has grown to over 2,500 algorithms, all freely licensed, and operated by a 501c3 organization.
In the software world, we all stand on the shoulders of giants, and it's by sharing our work and building on each other's work that together we can build these amazing software products.
The most important part of OpenCV is that it is free to anyone who wants to use it. Today, OpenCV needs your help if it's going to survive.
If you have benefited from open source, it is your duty and obligation to support it. I'm not asking you to help with a little bit of money. I'm asking you to fund the future of open source AI.
Included in the roadmap is a new deep neural network module, accelerated image processing, better TrueType support with full Unicode support, improved support for fisheye camera calibration, improved support for multi-camera calibration, and better support for depth cameras with brand new algorithms.
You have a common language for how to do things in software. You have a toolbox that you can pick up right away and start building with.
If you are a student, consider a donation of $21. If you are a working professional, open your wallet and donate a few $100s. If you are a high net worth individual who has significantly benefited from OpenCV, give your fair share back with a donation of $5,000. The future of open source computer vision and AI is in your hands. Don't drop it.
As soon as I got introduced to programming, basically I got introduced to OpenCV. I learned the basics of computer vision through those tutorials and those programs.
If you can't afford to contribute financially, the next best thing is sharing the campaign page with your networks. Write a personal note about why you think OpenCV is important and deserves support.
I love OpenCV, and OpenCV really changed my life, because with the OpenCV, I won't be in this field at all.
We love OpenCV.
I love OpenCV.
I love OpenCV.
I love OpenCV.
I love OpenCV.
In a world where massive AI projects are closed source and a handful of companies are set to control the future of AI, now is the time to take a stand. Will the advancements of the future belong to the few or to all of us? We hope you'll support OpenCV. Together, we can make history again. All right, so that's the campaign video there.
Jeff Powers is here.
Yeah, I see Jeff. Let's invite Jeff on stage here. All right, JRP, just promoted you to panelist. Go ahead and hop in.
Hey, hey.
Hi, Jeff.
Hey, Jeff, welcome. So,
Hey, Phil,
Jeff, why don't
Satya.
you
How's it going?
tell the people who you are here?
Yeah, who am I? That's a good question. So I am
Don't
Jeff.
get too philosophical. It's too early in the morning.
You've been trying to answer that for yourself for a while now.
Yeah, I think, therefore. So I am Jeff Powers. I am a computer vision entrepreneur, similar to people you just saw in the OpenCV video. I have founded a couple of companies doing computer vision, sometimes using OpenCV. in things such as 3D reconstruction, such as motion tracking, head tracking for VR, hand tracking, controller tracking, these sort of things. My current company is Arcturus Industries. We're working on next generation VR. Before that, I was the founder and CEO for a long time of Occipital. Occipital continues on doing 3D reconstruction in interior spaces, and a spin-out company built 3D depth cameras, and much use of OpenCV along the way.
Yeah, thanks for that. Can you talk us through a little bit of some of your early experiments with OpenCV?
Yeah, that's a good one. I mean, we definitely used OpenCV in the earliest days, more than a decade ago, for everything from, blob detection to camera calibration. Camera calibration was a big one. I mean, camera calibration with OpenCV.
Still a hard problem,
Yeah.
I mean, there's whole startups for that, like our friends at Tangram.
Yeah, totally. But yeah, that was OpenCV fisheye camera model was also a big one for us. We still use it, the Calibration model.
So we are actually one of the proposals for OpenCV 5 is to improve our calibration suite, right? So we do a very good job when it is a single pinhole camera, single camera kind of calibration. But as soon as it goes to multi-camera calibration, the support is lacking, right? And the algorithms may not be the best ones that are available. And also fisheye lenses, we do a reasonable job, but newer algorithms, newer camera models, they do a much better job, right? So calibration, improving the calibration module is one of the big items on the list.
Yeah, that would be great. Yeah, and even supporting some of these higher parameter models, so you can really fit the camera, and then you can speak to whether the particular model you've tested is actually a good fit for your lens.
Right.
Is a great would be great.
And also, with camera calibration, one of the most important things that people don't realize is it's very mathematical, right? I mean, the process is very mathematical, and so it is very important to have easy to follow tutorials, right? Which is also, the calibration team told us that, okay, it's not sufficient to just put out these algorithms out there. We'll need to create very high quality tutorials so that people can easily follow them. Because as you know, right, in calibration, you make a small mistake and you don't know what's going on, right? It's not like deep learning. You could make a lot of mistakes and it still works, right? Okay, it works at 90% instead of 95%, but it works, right? But in calibration kind of a situation, you make a small mistake and nothing works, right? So when you get it exactly right, everything works perfectly, but small mistakes lead to large errors, right? And that is why
at Occipital, we used to talk about the calibration dance all the time. And it is very much like a dance. You take one wrong step and you're on just way out there,
Yeah. And then other OpenCV things we've used over the years, feature extraction, orb features, brief features, sift, surf, all these things. So I don't know to what extent there's plans to add more, maybe deep learn features, deep learn matchers, things like that would be exciting.
Yeah, so the feature list for OpenCV 5 right now, it has come from the development team and some of our partners who are working with. But as we go through this campaign, right, we will ask people, our backers, for other features that they are interested in as well. And that could change some of the things that we are thinking about right now.
Cool. Well, I will bug you guys with feature requests then.
Yeah, please do. GitHub.com/OpenCV/OpenCV, I think is the URL. Feel free to submit a issue for discussion or whatnot. That's not just for Jeff. Anybody can do that, but especially Jeff. We're expecting it now. Jeff, do you have anything you wanna plug while you're here? What have y'all been up to lately?
We will have something to plug. We have been exploring new techniques in 3D reconstruction, and we hope to show some new results. There's things in the NERF and Gaussian splatting realm. We've been building some homegrown engines to do scene reconstruction for various applications, and so stay tuned for that.
Gaussian splatting is so hot right now.
Yeah, it's everybody's doing Gaussian splatting now, super fast. There's, what I'm excited about is in particular is how we can do things like neural scene completion and things like that. I mean, it feels like for a decade we were stuck with photogrammetry and flat textures and weird corrupt meshes and artifacts and things like that. And now all of a sudden, with NERF, we got view dependent appearance. And then with Gaussian splatting, we also get thin structures. So it seems like everything's almost solved, but one of the things we still haven't solved is what if the user doesn't, capture enough of the real world to reconstruct it. But as you can see, like with, stable diffusion, Midjourney, DALL-E, you're seeing you can invent a scene from nothing. So I feel like we're not far from being able to realistically complete real world reconstructions with a small number of inputs.
Yeah, it sounds really exciting. We look forward to seeing new stuff when you all are ready to publish it. Maybe we'll have to have you back on the show to walk us through it.
Yeah.
It was really fun last time for sure. We've got a question from the audience here. Tony, or no, I'm misreading there. Tiana would like to know, Satya, we talked a bit about multi-camera calibration and depth cameras, but are there any plans to add improved support for thermal cameras to OpenCV?
Sorry, I accidentally switched my.
Oh, good. We got any plans to add improved support for thermal cameras to OpenCV?
So thermal cameras, we are not 100% sure, right? There is a company we are talking with that creates thermal cameras as well as other industrial cameras. And if we get their backing, then we will have native support for thermal cameras. But right now, we do not have, in this roadmap at least, there is no plan for thermal cameras. But that would be very interesting. I mean, I'm very interested to get, if you can get, if anybody here, right, has any contacts with one of the large thermal camera manufacturers, and they want to help, they want to collaborate with us, I'm very happy to take on that task. It is surprising how, for all these industrial cameras, I'll just say it, how bad the user interface is for just getting a picture, right? You just want to get one picture onto your machine from a thermal camera or from one of these industrial cameras. It's a nightmare. You have to set like 100 different things before you can get a single picture. And
Some of them will have you installing like the Android SDK and all sorts of nonsense.
Even though there are standards, right? And the products are all commercial, right? Even though the standards are open, the products are commercial. You have to pay about $500 just to get an image from one of these industrial cameras into your machine, right?
Yeah, thank you for the question. Tiana, anybody out there who's watching, if you've got a question about the stream, about the library, about timelines, about anything really related to OpenCV today, ask your question in the chat wherever you're watching. We will do our best to work it into the flow of conversation as we have time, which we have a lot of today. We're going to be going for 4 hours. We've been going for about half an hour. Jeff, you can go ahead and drop off if you're whenever you want. Thanks so much for joining us here. Where can the folks follow you if they want to find you?
You can find me on, I guess, Twitter, X, whatever it's called these days. JR
I'm just saying Twitter.
Twitter. Maybe it'll be called Twitter again someday, I hope. JR Powers. You can find me there. You can also check out Arcturus.industries. our website. It's a little dated, but you can reach us there as well. So yeah, I'd love to hear from anybody, and good luck with the rest of the show.
Thank you so much.
Thanks so much,
Thanks
Jeff.
Bye, guys.
Thanks. Bye.
Excellent. So we will have another guest here shortly, but in between, Satya, let's talk a little bit about some of the features that are proposed for OpenCV 5. I think we can just kind of take it from the top. There's our main feature that we've been promoting here, at least that we've been talking about first when we talk about features, is new DNN module. Can you talk a little bit about that?
Yeah, give me 1 second. Let me share my screen. That would be the easiest option.
Go right ahead. Make sure that I'm allowing it.
Yeah.
Yeah, you can share.
Okay, so can you see my screen?
Looks good to me.
So, okay, so it's not really a new model, DNN module, but pretty new, right? We will do a lot of refactoring of the DNN module, right? And there will be new data structures, right, for 1D tensors, support for deep models. We will also have new data types like 16-bit. So these data types, when they are native, right, natively supported by the library, then all the processing becomes faster, everything becomes faster, writing code for the library becomes faster, etc. Right? So we will have native support for 64-bit integers, booleans, and B float 16. We will have improved and faster transformer models. Right now we have a transformer support, but it is very slow, right? So we'll make it faster for the core C++ implementation, right? So all of these are assuming that you do not have any accelerator, right? You're not running on any specialized hardware for which things are provided, right? The libraries are provided. So if you use core C++, right, on let's say a CPU, then all of these things are applicable. We are also having, we'll also have support for multimodal models. As you know, that multimodal models are models which just don't do vision, but they have other modalities also, like, you know, they could be text, there could be speech, etc. And for that, we have diffusion models, something called CLIP. It's a language model. So those things, we will have better support for it. And we have support for ONNX. So for people who do not know, ONNX is the standard for exchanging models from one format to other, right? Let's say you created, let's say you did something in PyTorch, you trained your model in PyTorch, and now you want to deploy it onto an edge device, right? One way to do it would be to convert your model into ONNX format, and then use it on the device. The device would know. So ONNX has both, the format as well as the runtime. Now, OpenCV, what we did initially, we didn't know, some of the problems with open source and AI in general, when things are moving very fast, is we don't know, right, whether ONNX would become the standard when we started working on it. So we supported ONNX in a haphazard way, in a sense that things that were necessary for most models, standard models, we implemented those. But we did not, you cannot say that, okay, OpenCV supports ONNX version such and such, right? And that is what we are going to change, that we will come up with a version that, okay, this is the version of ONNX we will support, and we will have details of the support also, right? Because even though we may support a certain version of ONNX, it may not be, some of the things may not be relevant for our library. For example, there could be, speech related stuff which may not be related to our OpenCV library, and we may not support it, but at least all the vision components will be supported, and any multimodal libraries we support, right, those would be supported. So very clearly defined support for ONNX, and this is very important.
Absolutely.
Then
let's pause here. We'll talk a little bit more about some of the other features later. Satya, you can go ahead and unshare your screen for now.
Okay.
Bring up our next panelist, favorite of ours, my sister from another mister, mi amiga, Paula Ramos of Intel.
Hi, Paula.
Welcome, Paula.
Hello, guys. How are you? Hey, Satya, Phil. Thanks for having me here. I'm so excited.
Oh,
What is new
the
here?
pleasure is all ours. Yeah.
Your studio is
so
amazing,
please-
Phil.
Thank you. This all credit goes to my brother Charles. We are at On Base Productions in downtown Niles, Michigan. This is his studio where he does photography, video production. He does shirts. He does all manner of things here in town. Chuck, you want to come on stream real quick? Just say hi. Say hi to Paula.
Hi, Paula. How are you?
Hi, how are you? Your studio is amazing. I love that. I need to stay there
Your
one day.
background and your sweater look incredible.
Yeah,
Paula.
Thank
you
you.
look so much classier than us, Paula.
Thank you, thank you.
Paula, will you please tell the people who you are?
So I'm Paula Ramos. I am AI evangelist, computer vision AI advocate at Intel, with more than 18 years of experience working in computer vision. I have a PhD in computer vision and machine learning, and I'm happy, to bridge the gap in between technology and users. So I'm really excited with all things that OpenCV is doing. I'm working with OpenVINO, by the way, for that reason is the confusion. So, and I think that the OpenCV, I need to say this because that was a great milestone in my life, and that was because of OpenCV. So I started at Intel 2 years ago, and that was because I participated in an OpenCV competition. And I opened the doors to new opportunities. So I have the proper visibility. So thank you, Satya. Thank you, Phil. I know that you are making a lot of stuff around the community, developers, engineers. You need to be proud of this team. We need to be proud and grateful with this team. So you are doing a great job.
Thank you.
Oh,
Thank
so
you,
kind of you, Paula. We really appreciate it. And as a reminder to folks out there, OpenCV AI Competition 2023 is ongoing. In fact, the deadline is November 30. We are seeing some really cool drafts of projects on the official competition page on hackster.io, and OpenCV Silver member in the official community platform of OpenCV. Paula, one of the things we had talked about for OpenCV 5 is additions to the OpenCV models, possibly including Anomalib. Can you tell us a little bit about Anomalib? I hear you're an expert.
Wow, this is amazing that you are including Anomalib in that. So Anomalib is an unsupervised library for anomaly detection, classification, and segmentation. We can find more than 13 algorithms to detect abnormalities. We are working with Anomalib at Intel with different kind of approaches, use cases. We can see manufacturing, healthcare, and also security. And we can see how Anomaly has been well received for the community, computer vision community. We show a demo in CVPR this year, and that was amazing. The people was stopping by in that demo. We have there the explanation of Anomaly, what kind of things what kind of algorithms we have, and the benefits to have those algorithms in one single platform. With Anomaly, you can train the model with some templates that we already have in the library. You can optimize the model using OpenVINO. You can also deploy the model in different frameworks. OpenVINO for sure is the preference, but also you can deploy that in PyTorch, in Onyx. So we have multiple options. And in that specific booth, in the demo, we also were showing how it is easy to run the inference using Intel hardware. So I think that Anomaly is a great example of how we are join dots here in between the training, the optimization, and the deployment. And it is great to have an OpenVINO model because you can write the model once and deploy everywhere. And for example, I have a use case with manufacturing. So you can put in Google Anomaly, and in YouTube you can see my face there. I'm feeling like a famous person. Because that video, I got like a 200K views in the first week.
Wow.
This is amazing, and we made a lot of effort. I mean, this was a great work with the team, but this is really, really, really well received topic. If you already have or you have the plan to include anomaly there, this is great. This is a great add for the computer vision community. We saw that there are a lot of things coming with generative AI, but it is still something that we can see that in the production systems, something that we are using, real solutions, is computer vision. Right. And with Anomaly, we are just covering in one single library, different algorithms. We have also CPU trainable models. We don't need a GPU. But if you have a GPU also, you can use that one.
Right. And I think these applications are very important for any library, right? When I first started with OpenCV back in 2001 or 2002, the very first thing I tried was actually, I needed a phase detector, and OpenCV had, the fastest, very best implementation of Viola and Jones or Haar Cascade phase detector. And that's what, that was the, that's how I got started. And then I discovered, there are so many different things in the library that I did not know, right? And finally, that became the library of choice for me. But the same thing applies to something like Anomalib also, right? Once you, it's a very important thing. And there are not very many models out there that does what Anomaly does, right? So it can be very useful for OpenCV, as well as it's already implemented in OpenVino, and we'll try to see how we can incorporate it into OpenCV models as well.
That is amazing, Satya. That is, we could see that more industries, real use cases are using Anomaly. So we saw, I receive maybe once per week a message in LinkedIn asking for how they can include a data set. They are facing some issues with some data sets and other kind of libraries, and Anomaly is helping them to digest new data coming in the production system. So more things are coming, I know, but also when we have the inference running with OpenVino, it is great. We have, and this is just have this in mind if you need to make the decision to include OpenVino. In the last year, we can see the growing of OpenVino in a 90%.
Wow.
And we can see how more and more developers are finding useful OpenVino for running the inference.
Right.
But not just that, the optimization part. And just join this with Anomaly. Another thing that we have is for optimization, for example, we can create optimizations pipeline with Anomaly with just running the API and selecting the OpenVino as the tool that we want to use for optimization. We have the neural network compression framework, and it's as simple. So you don't need to be an expert in optimization. That is my point. Right. And that is also the view that Anomaly has, is a friendly library where you can find a lot of algorithms.
Right. And, for people who do not know, OpenVino is the optimization library from Intel. If you have a model and you want to run it on Intel processors and even on other processors, and you want to optimize it, you can, you can reduce the size of the model, make it run faster, and all those nice things by just running it through one or two commands in OpenVino. And I had personal experience. The first time, it became part of our standard pipeline is we were working on a video background removal application, just like, you remove background in Zoom. And we were getting about 10 frames a second. We had a high quality model, but we were getting about 10 frames a second, which was not enough. And just by using OpenVino, so we used our standard model, we just used OpenCV on it and OpenVino on it, and suddenly we got 30 frames a second, just like that, right? No changes. And that's when, we just made it part of our standard pipeline. Whenever we want to deploy to CPU, that is our standard pipeline.
That is amazing. And with all capabilities that we have right now with OpenVINO, we can see, more things like this. And also we have support for different kind of hardware, not just Intel hardware. So we have also support for ARM, for example.
Right.
And this is also great to see that we can pip install OpenVINO in a Raspberry Pi. So it's great. It's great for the community. I think that in my case, in my perspective, you know me, I love to make different kind of do-yourself projects with my son, with my husband, and we have a lot of stuff around. And we always use OpenVINO just to optimize the performance at the end.
Right. And you're also representing. You're actually the great ambassador for OpenCV because you're representing Intel. Which has been, OpenCV actually was born at Intel. But not only that, you are also a participant of the OpenCV AI competition, right? So there are all these various angles through which, you are a perfect ambassador for OpenCV for us.
Satya, when I started making computer vision image processing in Colombia, some years ago, I will say more than 15 years, I was using OpenCV, and I have never had in my mind that I would have a conversation with you, with Phil, involved in this community. Right. And when I started working at the university, because my background was, my previous work was working with agriculture. And we work with the agriculture and involve OpenCV in the pipeline. And we can see how easy is also work with computer vision with OpenCV. I think that you are making our lives easier, for sure, because we have a lot of subject matter experts around. So I was working with agronomists, biologists, and they clearly understood at that time how these things was working. And I think that also we motivate them to continue the legacy. They already are working on that. They are already working with OpenCV. And this is also because you are putting a lot of efforts to make this more friendly for developers and users in general.
Yeah, all credit goes to all the developers who have worked on OpenCV for the last 20 years, right? I'm just the face right now, but it's all the development effort that has gone on for the last 22 years.
The face that runs the place.
And also, talking about grad school, I also feel that when I was in grad school, right, things were not as open as they are now. So there were these, you can find labs which had a lot of resources, right? They had developed their own internal computer vision library for 4, 5, 6 years. And new labs could not compete with them. We could not, even to do simple algorithms, you had to implement canny edge detection, you had to implement Huff transforms, you had to do all of these things which they were not available, right, at that time. And the only other option was to go and get a license for MATLAB, right? And that was an option. A lot of people tried that option, but MATLAB, as useful as MATLAB was at that time, it was also, first of all, it is expensive, and you cannot, in the real world, using it, it becomes very cumbersome, right? So OpenCV, what it did, it made it
a lot of scientific software, not the most user friendly.
Right. So OpenCV democratized, right? Now all the labs from many different universities, from many different research labs, they were on equal footing. At least the basic standard computer vision libraries were available to everybody. And now, now the best ideas would win. So that it's not like, it was funny to see how academia, which, we try to pride ourselves in being open about things. But when it came to code, people were just hoarding code. They were not releasing code. Part of the reason was that they did not want to expose themselves to criticism. But part of the reason was also that it helped them write papers, which other people could not write immediately, right? Just because of this barrier to entry was high. And OpenCV completely demolished that barrier.
That's true. I remember when I was working with coffee, because I was working in the National Research Center of Coffee, I create a lab, a computer vision lab there. Engineering lab in general. And I have MATLAB. I have the license of MATLAB. I was working with a Gonzalez book. That was iconic book for image processing with a lot of examples. And then I moved to OpenCV.
Yeah.
But the good point with OpenCV was I was able to find examples. Even at that time, I think that you were writing those examples.
Well,
because
I was writing the example starting 2014.
Okay, so maybe no.
Yeah.
So it was, and maybe.
I mean, it's totally possible that Paul is a time traveler. We have not ruled that out.
Perfect. Thank you, Phil. So, and the point here is that with all the examples, even if we have, beginners, they can follow as a simple, the coding mindset. And I think that also we are changing the mind of a lot of people. And when I say we, it's also because I really advocate to use, computer vision codes, OpenCV, also, OpenVINO for inferencing. So, and when we have this kind of libraries, when we have this kind of tools, we can democratize the technology for sure. And we will see more things coming in the future because this is changing every single week.
Thanks.
So thank you, Satya. Thank you, Phil.
Thank you, Paula. Thank you so much. If the folks out there want to find you on LinkedIn or social media, where can they find Paula Ramos?
I'm a LinkedIn person, so you can just find me as Paula Ramos, and you will see my face there. Maybe there are a lot of Paula Ramos, but you can recognize my face.
And at Intel, right? So.
At Intel, yes, at Intel.
That's right.
So thank you, Satya. Thank you, Phil, for having me here. And good luck with the campaign. And this is exciting. I'm so excited to be here.
Thank you.
Yeah,
Thank you.
I really appreciate you, Paula.
Take care.
Yep. Bye. Have a great day. Paula's the best, isn't she?
Yeah.
We've got our next guest will be here in just a little bit. We'll be joined by Vikas Reddy of Twist, who I've known for quite some time. He's a co-founder of Occipital with Jeff Powers, our first guest here. But I think, before we do that, Satya, let's talk a little bit. Hank, you're clanging over there. Just something for Phil to edit. Satya, let's talk a little bit more about another one of the features over OpenCV 5.
Yes. So can you see my screen again?
Sure can.
Okay. So we talked about the improvement to the DNN module. Another one that is coming is, accelerated image processing. It has two components. First of all, OpenCV was written when the library was started. It was written for, video processing was a big deal, right, for OpenCV. It was created for real-time computer vision. And so most of the image sizes, right, we did not think that we were going to process very large images, right, something like 6K by 6K, 32K by 32K images. And that is why a lot of functions inside the library, they don't work for large images. And when I say it doesn't work at all. It's not like they're slow. They don't work at all because the indexing is done using the number of bits used for indexing is not enough for that size, right? And so those kinds of things we'll need to fix now that large image formats are pretty standard. So that's one piece we are going to fix: large image support. And also existing image processing, we need to make them parallel. A lot of those, some of them have parallel implementations, but others do not. So we'll make image processing, parallelize them so that we have fast image processing for very large images. So that's another one. Do you have more time?
Yeah, that's great. I think we got time for one more feature if you want to talk a little bit about. Yeah, this would be great.
Okay, so the other one is scalable SIMD architectures. So there are these open architectures like RISC-V, and RISC-V has this extension called a RISC-V vector extension, RVV, and OpenCV will use that, will support that so that we can optimize it for RISC-V chips. A lot of chips in the future even now, they will be based on RISC-V architecture because it's open, and so having this acceleration would really help. And we'll also have better support for ARM v8 plus. What it means is that ARM v8, I think version 8.2 or so. After that, there was this. There are new. For parallel implementation, right? For vectors, there is more support, right? There are more instructions that we will use that under the hood, so that people will not realize, okay, none of the functions are changing, but things are much faster on ARM v8 plus architectures. So that's another one. RISC-V and ARM v8 plus, things will be much faster for SIMD architectures.
Excellent. It's one of those things people have definitely been sending questions about and messages about on GitHub and into the newsletter and things like that. We always get a lot of messages about different architectures, and so it's nice to be able to tell people good news on some of the more popular ones here. I'm definitely interested in RISC-V. Could be a pretty big step for a lot, especially for embedded stuff. But let's take a quick look at the campaign. Do a campaign page update. Let's have a looky-loo. Looks like we're sitting on refresh here. It looks like your donation went through, Satya.
Yes, my donation went through, and I'm kind of sad that my donation still exceeds the combined donation of everybody else. We have to get.
You more than doubled the. Yeah, folks, please share the link. Talk to your boss. Talk to your spouse. Talk to your dog. Let them know about the good news about OpenCV 5 and what we're trying to do here. It's more than just about OpenCV. It's about preserving access to the best tools for everyone and not just the people that can afford to pay for them. And it's very important to us. It's personal to us. And if it's personal to you, I hope that you will help us out. I think now's a good time before our next guest. I think we should go back over to the music here. Get in here. You switch me? It's all good. Am I on? All right. Henry, this is my nephew, Henry Nelson. You saw him playing earlier with the Mayflies with his mom, Jess. Hank, thanks for joining us and thanks for being so patient here.
No problem.
Your outfit's tremendous.
Thank you.
What are you going to be singing for us today?
I'm going to be singing Big River by Johnny Cash.
I love it. I love it. Ladies and gentlemen, theys and thems, Henry Nelson.
Now I taught the weeping willow how to cry, and I showed the clouds how to cover up a clear blue sky, and the tears that I cried for that woman are gonna flood you, big river, and I'm gonna sit right here until I die. I met her accidentally in St. Paul, Minnesota, and it tore me up every time I heard her drawl, southern drawl. Then I heard my dream, went back downstream, cavorting in Davenport, and I followed you, big river, when you called. Oh, get it. Well, you took me to St. Louis, later on down the river. A freighter said she's been here, but she's gone, boy, she's gone. Well, I found her trail in Memphis, but she just walked up the bluff. She raised a few eyebrows and then she went on down alone. Why don't you bat it down by Baton Rouge? River Queen, roll it on. Take that woman on down to New Orleans, New Orleans. Go on, I've had enough, done my blues out in the Gulf. She loves you, Big River, more than me. Oh, come on. Now I taught the weeping willow how to cry, cry, cry. And I showed the clouds how to cover up a clear blue sky. And the tears that I cried for that woman are gonna flood you, Big River. And I'm gonna sit right here until I die.
All right. Thanks so much, Hank. You're the best, buddy. 15 years old, folks.
Wow. Awesome. This is
all right.
This is great.
So our next guest is here, Vikas. Vikas Reddy, old friend of mine, hired me at Occipital, my first gig in the computer vision business, as it were. We did a lot of awesome work together. We built some really crazy web stuff on really short notice, and I learned a whole lot from him. We still do work a little bit together here on his new startup, Light Twist. Some of you may remember from some other episodes of OpenCV Live. Welcome, Vikas.
Hey, thanks for having me, guys. This is super exciting to be here. Yeah, I'm long time user of OpenCV. I guess since probably about 2007, maybe even. So yeah, long time user, first time joiner of a live stream for OpenCV.
I think you have been on our webinar. Oh, actually, that was
he's been on the web. He's been on the webinar.
Yeah, that's true. I've been on the webinar, but yeah, first time at least for this campaign event, I guess I should say.
This is your first time joining the chaos stream.
Yeah, Phil, I like your setup there in the desk too. That's
again,
really nice.
all credit goes to OpenCV, or all credit goes to On Base Productions. My brother Chuck. Also, hey, thanks so much. Yeah, Hank, say goodbye to the folks here. Hank's gonna get out of here and go do kid stuff.
Sounds
Thank
good.
you so much for having me on, and I was very glad to play. Thank you very much.
Awesome.
Thanks, Henry.
Thank you, Hen. You're the best. So Vikas, yeah, I don't know if you saw earlier in the show, our first guest was your old partner in crime, Jeff Powers.
I know, I saw that. Yeah, I was yeah, now I got to figure out, I got to make sure that what I say is differentiated, so it doesn't sound like a repeat.
in some way, right?
Yeah.
Yeah. Could you talk a little bit about your early experience with OpenCV? You were talking about 2007. That's a little while ago. That's just before Hank was born, I think. So
yeah, I mean, back in, it was yeah, I mean, that was like let's see, like I think that early on, yeah, I mean, I think probably a lot of what we were doing early on at previous company, my previous startup, Occipital, was with OpenCV was a lot of it was around prototyping stuff. So yeah, I think we used it on every product in some sort of way, except for yeah, in some way, just for prototyping or something else. And so yeah, early on, it was just like we were doing some experimentation with essentially trying to build a product that was maybe akin to Google Photos today. We used it for prototyping around the red laser application for barcode scanning, some smaller aspects of it,
which was acquired by eBay.
Yeah, acquired by eBay in 2010. Yeah, I mean, it was super useful. I'd say like a lot of in the early days, the mobile phones were pretty slow processors. So what we'd end up doing is implementing something, or even kind of prototyping something on the PC, and then there was sort of a rough number at the time, which used to be maybe 50x. So if something ran at if something ran at a certain speed on PC, it would run about 50 times slower on the phone. And so we would have to be like, okay, it was a good sort of like benchmark to hit. So we would usually prototype a lot on OpenCV for, especially a lot of the lower level functions were actually quite useful. So even basic stuff like image loading, like region of interest cropping, like things that are not like, honestly, nothing. Some of the lower level functions aren't like rocket science, but they're actually quite useful, saving a bunch of time. It's almost like in some ways, OpenCV is like a domain specific language for computer vision, right? It's like it's a layer that you can build on. And so yeah, we used it for that, and then we would re-implement a lot of stuff on in different ways to actually run super fast, but at the prototyping level, it was super, super useful. And yeah, I think later on,
the term is, it's not rocket surgery. Get it right.
Yeah. That's true. Yeah.
I mean, while we are at it, I would love you to also tell us a little bit about, the massive success of a very small team, right? For the barcode scanning application that you built. And this was the very first version of iPhone, right? Am I correct in that? It did not have autofocus. And you implemented this, you prototyped this using OpenCV, and then implemented this on iPhone. What was the level of success? Like how many downloads? And even if, you had mentioned last time, the commercial success also, people who are listening would love to know, because many are having their own company.
Yeah, at the time, I'd say it was a good, like, it was a platform shift type scenario. So there was like this new platform, the iPhone. And so maybe the analogies today would be something more like VR or spatial computing, or maybe even, an AI for sure. So it's like there was an opportunity there for a small team, because it was a new platform that like a lot of the bigger companies were still figuring out. And so we were able to get something going. And so, yeah, like we're using OpenCV. We, not for everything, I should say, we were using it for a lot of the more basic stuff, like at the time, probably because the barcode scanning algorithm itself was novel. But yeah, we ended up, prototyping it, shipping it. I think we shipped the first version in July 2008. Oh no, sorry, 2009, July 2009. And then I went through several iterations, and then like by September, we were making like, maybe like $50 a day or something like that, or something very small, until we kept iterating the algorithm and the user experience. And then finally in September, we kind of hit this, like, we kind of cracked the code on how to do it, one in real time. I mean, by real time, I mean 2 frames per second, but close enough. And then and got it to barcodes. Good enough for barcodes. And then we figured out all the right data to pipe into it. And then it started taking out virally. So we had like, I think it literally looked like we had like 50 sales one day, and then 100 sales, and then 200. And then I think at its peak, it was making, it went from like, wherever in the App Store up to the top 3, I think. And then it eventually got to number 1 for a while. But it was, at some, its peak, it was making like $40,000-$50,000 a day, which was kind of insane.
So $40,000-$50,000,
especially because how old were you and Jeff at the time?
I think I was I think I was maybe 24 and Jeff was 25, maybe. I'm not sure about the exact numbers, but something in that range. And then and it was a relatively self-contained app, and not too heavy in terms of different moving pieces and stuff. And I think because it was our ability to kind of iterate quickly and prototype rapidly was helpful, because just being able to ship it quickly on this new platform. We weren't like one of the first apps on the App Store, but we were probably one of the first apps to heavily use computer vision on the App Store. And we were the first barcode scanning app that actually worked well for barcode scanning. So given like the constraint you mentioned, Satya, which is that they had a fixed focus camera. So it was super fun. It was like kind of a crazy, I remember talking to Jeff, and we honestly were like, we just built it because we're like, okay, we want to go do more exciting things, but like we just need to go make some money. So let's go build this stupid barcode scanning app. is like, I think we were kind of like annoyed that we had to build it in some ways. And so we just did it to like get some capital in. And then, yeah, we were able to use that capital and success to go and do bigger things with, with our second company, with Occipital. So after Red
it's
Laser.
often those things you least suspect or expect that have the biggest payoff. It's you got to keep buying those lottery tickets, and one of them pays off eventually if you're lucky.
That's true.
Would you like to, Vikas, talk a little bit about what you're doing these days with LightTwist?
Yeah. So with LightTwist, we're building a virtual video studio in the cloud. So instead of having to build a physical video studio and like fly everyone else together, or just doing something more, kind of 2D on Zoom, we're able to, what we built is a web application, essentially a cloud-based application that takes a webcam, an iPhone as input, and you can essentially render, we essentially in real time render people together in the same virtual studio. And so we're using Unreal Engine 5 on the back end. We're using some deep learning for things like segmentation and kind of like a more advanced green screen algorithm, experimenting with some of the things around, doing motion control and like sort of avatars. And so there's a bunch of stuff on our roadmap, but the core product is you get a realistic looking virtual studio on par with something that, looks like SportsCenter, or could look like, Jimmy Fallon's late night show, all with just a browser and a webcam. So using a lot of computer vision and using a game engine, and then a lot of software and design to kind of tie it all together. And yeah, again, with a pretty small team. So it's only 2 of us full-time, myself and my co-founder Gustavo, and then we've got a couple people contracting with us on design and a couple other things. So yeah, it's been pretty fun. And I think I did a talk on the OpenCV webinar, I think a couple months ago. So
yeah, that's right.
Yeah.
Awesome.
Yeah, if I didn't think about it, I should have asked if we could show an episode of the game show we've been working on here. It would have.
That's true. Actually, that would have been cool.
Yeah, it would have been.
Yeah, I don't know if we have permission for that, but yeah,
bathroom break.
Yeah, one of our early customers is building a pretty cool game show. That
Can you do me a favor and text Ajit and ask?
Oh yeah. I'll
if we can show one.
Ping him. Yeah, I'll ping him.
We've got 3.5 more hours to go. No.
Oh man, nice.
However many hours, I don't even know.
That's cool. Yeah, I'll text him. But yeah, let's see. There's some questions in the chat here. It looks like.
Yeah. I'm gonna pull a couple questions here. So someone was asking about how the campaign funding will be used to develop OpenCV 5. We talked a little bit about these are the proposed features, but people are wondering a bit about exactly how the money will be used. On the campaign page, we actually break down a couple of the larger features and what the expected cost is. Satya, you've mentioned here, we're hoping to have it out 6 months after campaign end.
Yeah.
And could you talk a little bit more about exactly how the funding will be used?
Yeah. So in terms of, it completely depends on the level of funding, right? Let's say we are able to raise $500,000, right? In that case, the funding can, one of the key areas that we are lacking is, we have the co-developer, right? Let's say the person who is able to accept pull requests, right? We have very few of them. In fact, we have 2 of them right now who have the knowledge to accept pull requests, right? And that is a very dangerous situation, right? That we have only 2 people, because these are senior level people. They need to know, they need to have a deep understanding of C++. They need to have a deep understanding of computer vision, and they need to have a very deep understanding of processor level optimization, right? Because we make one little change and things can go very wrong, right? So one of my, one of the key things that I want to do is have another person, another co-developer who is at that level. So this would be a C++ developer who would be able to work with OpenCV over the long term. and we will have, one extra person on the team right there. For other features, we can have part-time people. For this particular feature, right, for this particular long-term maintenance of the library, we need one code developer who is at a very high level, C++, computer vision, as well as processor level optimization, who understands these things. And then we have, these other features that we talked about. Some of the features we may be able to pull off using interns, right? And Google Summer of Code, for example, is very influential in getting new features out for us. In Google Summer of Code, Google pays the interns, and then there are mentors who basically donate their time mentoring the people, the students, right? And we want to have OpenCV interns as well, directly funded through OpenCV. Again, we can easily get mentors who do not charge us anything. And so that way, some features can be developed, less expensively using interns. But again, the core features always need developers. And as I mentioned, that 100% of this funding is going towards the development effort. We are not going to touch a single penny for any other purpose. All of it would go towards developers, right?
We're not even going to pay Satya's $2.05 that he's owed by the Open Source Vision Foundation.
That's right.
How serious we are about this. I'm not getting a dime. Satya's not getting a dime. We're going all in on the library here. So,
Phil, I saw a question from Satvik about OpenCV. I was going to answer or attempt to answer that. Do you mind if I share my screen?
Yeah.
Go ahead.
All right. I'm going to do, let's see if,
Satvik had a question, which was the short path to learning OpenCV, and this is Vikas's, now I'm seeing troll answer. Go ahead, Vikas.
Well, no, it's not. It's actually not a troll answer. This is actually like, I would highly recommend this for,
no, it is actually, it's kind of upsetting how useful this is. Yeah, go ahead.
Yeah. So I'm actually curious. So let's see. So let's say if I type in, maybe I'll start with something simple. So I think the question was like, how do you get started with OpenCV? And like, just start prototyping and things. I think in general, I'd say my advice for all of this type, if you want to learn something new, it's I think just kind of learning it generally can be useful. And it depends on how you kind of like to work, but there's tons. I'll let Satya answer later about the courses that OpenCV offers. There's tons of those that are awesome. But the way that I like to learn is just like having a specific thing that I want to build that I'm excited about, and then just use that as a focusing function to try to like build that thing and actually ship it, or like have it in a place where either I can play with it or I can let other people play with it. So maybe for fun, I'm actually just curious to see, like, let's say, I guess maybe we'll use Python, I guess, right? Like, so maybe I'll say like, can you write me? And by the way, I'm using ChatGPT for just to, the reason I'm using this is like, I do think it's actually very useful for beginners because it can give you sample code, it can answer questions, it can even adjust stuff. And so it doesn't mean you get to use this for every line of code, but when you're just getting started, I've used this for a bunch of different things that I'm trying to learn. So even like Unreal Engine 5, which I was pretty new to. So I'm just gonna say like, let's use like barcode scanning just because I'm actually curious if this will work. So let's say like,
it's a great call.
Can you write a sample application using OpenCV, I guess 4, right? Or just, I guess I'll just say OpenCV.
It doesn't, just say OpenCV.
Yeah, using OpenCV, and maybe I'll use Python since it's a little bit more friendly. For beginners in Python. And so let's see. First, it loads a image of a barcode that's on the hard drive. It will like finds a crops a region of interest. For now, let's just assume it's fixed.
And you're all getting a free course in ChatGPT 4 prompting here as well. There's people on YouTube charging a couple $100 for this, Vikas.
Oh, nice. Yeah. And then let's see, crops a region of interest, and then like, scans the barcode. I guess we can say like, you can assume there's actually two different types of barcodes. There's like UPC and EAN. So I don't know, you can, maybe let's, it should ideally handle UPC and EAN barcodes. And, and I should say these are, this is for a sample application for 1D barcode scanning. Actually, I'll just put it up here. UPC and EAN. Okay, and then let's see here. I guess we can say that it will, so scans the barcode and prints out the number. Trying to think of anything else that we should mention here. Interest. Oh yeah, I guess it's okay to use third-party libraries if they are open source. All right, let's see how it does. Okay. Okay, so OpenCV Python. Oh, PySbar. Nice.
Yeah.
Okay, great.
We got our ROI.
All right, nice.
Yeah.
So it looks like import CB2. It's doing it's got this, I guess there's a PySbar open source project. Yeah, PyZbar. Nice. Oh yeah, ZBar. Yeah, nice. And then
ZBar is the main and then the Python version is the PyZbar.
Yeah. So this is kind of a good, so you can see it's got good things, and then you can start to modify this. You could maybe be like, let's see, you might be, can you adjust the code? Can you adjust the code to handle?
I like how you turned off caps lock there, like you didn't want to be rude to the machine.
Oh, I definitely don't
Sorry
want
for
to
yelling,
I don't want to be.
computer.
Yeah, I don't want to be hunted down later by the AI when it's like looks over its history and sees that I'm new to it. I'm already teaching my kids to be nice to AIs too, just in case. So
the same thing.
Yeah, it is not known. So yeah, let's say, so let's see here. So I'm just adjusting it now for like whether it's this. So I mean, it's possible that this code won't exactly like run or compile exactly as is, but it honestly might. It looks plausible to me. Yeah. I wish I had a.
It passes the smell test.
Yeah, it passes the smell test. So, sounds like to answer, probably to answer your question, I'm saying, I think having a specific application in mind and then using some of these AI tools is a good strategy. And then maybe, Satya, you could probably talk about the courses as well.
Yeah. So this is great. I mean, this the first thing that it does is that it gets you started, right? Which is very important. Otherwise, if you're bogged down by little details, then you don't get started. It is overwhelming, right? So this is a great way to get started. But there are two levels at which you can learn, right? You can learn at this level where you know how to use the library, and it is great for people who are building applications, etc. But for people who want a career in AI, right? For them, it is very important to know the foundation of how these algorithms work, right? So, for example, face detection or face recognition, right? You can use it while building an application using OpenCV. It provides all the tools for you. However, if you want to know the basics, how the algorithm works, right? Then you need structured learning, right? And for that, we have several courses, right? In fact, you can support in one of the tiers that support levels we have the courses also. You can buy all the courses that are offered by OpenCV University for a price, and 50% of what you provide, 50% of your support will go to OpenCV, and the remaining 50% will go to the OpenCV University team, right? So those courses are great for building a very strong foundation, and especially for people who are trying to build a career in AI, right? They want to go and crack a job interview, right? For that, you'll be asked about the fundamentals, right? And for those people, I highly recommend that you take OpenCV University courses, and that in turn supports the OpenCV library as well, because part of the revenue is shared.
Yeah, totally. Vikas, first, how was Halloween trick or treat at the Reddy household?
Oh, it was great. The kids were super. Got 4 kiddos now. I've got my 2 nephews and my son and daughter. So we got 3 boys and 1 girl, and it was they were pretty solid at we hit up the street with a lot of the great best candy. They filled up like a whole probably like 40,000 calories worth of candy each, and so yeah, it was a good haul for sure. And then they were dressed as three.
Here.
Yeah, it snowed here as well. It was snowed a couple days ago, so it was a little colder. But yeah, we had 3 Grim Reapers and 1 Princess Anna from Frozen. So
excellent.
It's funny. I tried to call her. I was like, "Hey, Ro." her name's Ro, and I was like,
"Yeah."
When she was wearing the costume, I was like, "Hey, Ro," and she's like, "No, I'm Princess Anna." And
Excuse me, Dad.
So,
Kayfabe.
Yeah, I know. Yeah, she was definitely kayfabing there. Yeah, it was good.
For those that don't know, I gave a presentation on kayfabe, the pro wrestling concept of keeping the artifice of pro wrestling alive at the Light Twist Retreat in Toronto. So.
Yeah.
So Vikas, where can folks find you if they want to follow you on the social medias or the professional networks, et cetera, et cetera?
Yeah, you could. I mean, anyone on the stream, you're welcome to. I'm pretty responsible on email. If you ever want to ping ideas or startup stuff or really anything in the computer vision, deep learning, like AI space, like I'm super excited about that stuff. So I'll post my email here, and then I'm Vikas Reddy on Twitter. Feel free to find me there. And we're if anyone on the live stream happens to be in the market for a virtual studio, obviously hit us up there too. Other than that,
I gotta get you all on
Gary's
Mastodon.
Here.
Yep.
Yeah,
I gotta make the switch to Mastodon, man.
Yeah, I don't know. Yeah, I'm too.
The vibes are much better over there.
Are they better over there? Yeah, maybe I'll try at some point. So, I see Gary's joining us here too. So, I think, hey Gary, I'll drop off here unless you guys are.
Hello.
But thanks so much for having me.
You're free to go, Vikas. Thanks for joining us.
Thank you so much, Vikas.
I dropped a donation. I don't know if I get a floppy disk or not for my donation. Do I get an actual floppy disk?
I mean,
that would be amazing
for you.
Yeah,
I will see what I can do. I have a floppy drive at my house.
And then I'm super excited. And thanks. I just wanted to say again, the OpenCV has been amazing. Like it's a huge source of it's one of the core software libraries that help push the state of computer vision forward, especially the last 20 plus years. And so hopefully that continues, and good luck guys on the rest of the campaign.
Thank you. Thanks, Vikas.
Yeah, thanks so much, Vikas. Joining us now, we've got the founder of OpenCV. With me on the stream right now are the 2 people that have donated $5,000, the CEO of OpenCV and the president of OpenCV, Satya, Mallick, and Gary Bradsky. Welcome, Gary.
Hello.
Well, let me set the stage. Let me set the stage for...
Go right ahead, Satya.
Yeah, so people, a lot of people may not know how influential Gary is in the history of AI, right? And we'll talk about some of it in a bit, but I think Gary is easily one of the top 10 most influential people in the history of AI because Gary is the founder of the OpenCV library, right? He started OpenCV 22 years back at Intel, and he has been the key force driving this, right? Getting funding for the library while working with different companies to get it working for 22 years, right? So he's, and just imagine, right? OpenCV is used by NASA, it's used by Google. If you go and search on YouTube, look at YouTube's credentials, YouTube uses it, Facebook uses it, Instagram uses it. All these companies use OpenCV a lot, 2 million downloads, 2 million downloads a week. It's changed the way computer vision applications are developed, right? So easily one of the top 10 influential people in the history of AI. And there is another major thing Gary was part of, and I'll let him talk about it himself. The first autonomous driving project called Stanley, which won the 2005 DARPA Grand Challenge, was, Stanley won that. The car named Stanley from Stanford won that, and Gary was part of the vision team, and OpenCV library was used
in that, under Gary's leadership. So Gary, I would love to hear your thought, the story about Stanley. We can begin there, or wherever you want to begin, the story of OpenCV, how it started. That would be great for the community.
Folks in the chat, if you're watching, you've got a rare opportunity outside of the trade show or convention environment to ask Gary some questions. So post them in the chat wherever you're watching. Gary, how you doing?
Pretty good. Yeah, OpenCV started in a previous millennium, long, in the prehistory. As
in the
a
before time,
project,
in the long, long ago.
As a project on my computer. OpenCV started when I joined Intel. I was getting out of grad school, and I joined. I did a stint in investment banking, and I hated it, despite it being well paid. So I decided to get back to research, and I joined Intel Research Labs. I moved back to California from the East Coast of the US, and I joined Intel Research Labs, which was forming at the time, but I was also helping they had a Intel Performance libraries. This preceded, OpenVINO and all that stuff. So I decided to push for an open source library. We were traveling around the world, really looking at computer vision labs and things. And one thing I noticed was that, well, at the time, everybody was implementing their own code. It was very difficult to reproduce any project because it was all some spaghetti code on some grad student's disk. Very difficult to replicate any experiment, except at a few places like MIT. They have their own libraries that students use. So I just decided, why not democratize that and give everybody a better baseline to work from, stop, because a lot of the computer vision at the time was stuck in reproducing simple stuff, and so lots of implementation of canny edge detectors and calibration, all often done wrongly, and so I thought, let me just enable people to start out at a higher level, and also to allow reproducibility if they built it on a structured framework. So I started, open source library. I just started doing this. There wasn't really an Intel policy at the time, but internally I was lobbying for support. I grabbed resources from some Russian teams that they had, and we started doing it. Eventually, Pat Gelsinger is now CEO. He gave a go-ahead, and then we were off and running officially with this. And I think it was the 1999 CVPR. We had the first alpha. What?
2000 CVPR.
Oh, 2000.
Just one past a good Prince song.
So that was its first alpha release. And I'd like to say, in life you have a lot of plans, and then a lot of things happen as usual, and often your plans don't go exactly how you wanted.
Man plans, God laughs, as they say.
And you end up in different places. This OpenCV was one of the few ones, because Intel at the time, different era, had this problem that there were, it was already fast enough to run spreadsheets and Microsoft Word, and what else did you need computers for? There was this thing, that was starting called the net. I mean, it was around. It wasn't fully integrated. It didn't really have images for a long time, and it was text. And so they didn't really have a sense of, okay, Intel wanted to make faster and faster processors where they got their margin from, but there wasn't necessarily a demand for them. And so I thought, well, computer vision will have endless cycles. And, the field really needs some kind of standard to help it get to a higher level. And, I thought, I'm not going to be at Intel forever, so I want to take my work with me, more or less. So all these things were achieved with OpenCV. And, then it started going along the way. OpenCV was used. Sebastian Thrun was this up and coming researcher, and I was in contact with him, and I invited him out to Intel as he was on sabbatical. So he came out to Intel in Santa Clara, California, which isn't too far from Stanford. It's maybe 10 miles or whatever that is in kilometers, 15 kilometers. And he told me secretly that he was actually, in discussions with them to move from CMU to Stanford. And so, he invited me also. Well, subsequently, my sabbatical, Intel gave researchers a sabbatical. Subsequently, my sabbatical came up. By then, Sebastian had joined Stanford, and he would occasionally, visit Intel, but he joined Stanford, and I was looking around the world. I was going to go to Switzerland for my sabbatical to a research institute, but I talked with him, and he goes, "No, come here." And he said, "I'm going to be working on this autonomous car." And so I went there and kind of headed up the computer vision team. Back then, LiDAR was the thing, and no one was thinking to drive by computer vision. So we started that effort with a whole bunch of others, at Stanford. And, the long and short of it is at one point, the camera kept breaking because it's hard conditions out in the desert. There's a lot of vibrations and dust. And we had a stereo camera, and the camera kept falling apart. And so Sebastian told me that, this is all for your edification. We're not going to do computer vision on the car. And that made me double down. And so we showed him that the car could not drive fast enough, long enough without vision. And so it was put on Stanley, this car, for the 2005 DARPA Grand Challenge, and we won. So it was a $2 million prize, and we won. The prize went to Stanford, but that car is now sitting in the Smithsonian Museum, in the Air and Space Museum in Washington, D.C. You go on the second floor, go down to the navigation room, and you'll see it there. And so, it became a part of history and launched the autonomous car kind of industry. By then, I'd moved on to Willow Garage and many other things. But so throughout my career, I've kept OpenCV going now, and I've been doing startups and have all kinds of them. Now we're kind of focusing on really putting the foundation, OpenCV, on better financial footing. So this is the start of it, and 5.0 has been a subject which is really a revamp and a cleanup of the library, optimization, and adding these new features. And it's been like a progress on it, but we haven't really had the resources to push it over a threshold. And so it's such we've been talking about this. Well, how do we get out of our, it's been a long time. We've never pushed this thing out. How do we get the resources to get this thing out and start, setting a higher foundation for the foundation that's supporting the computer vision, and so the idea of this fundraiser came out. So hopefully you'll give. I just donated my successful individual in the field amount of
yes,
$5K. So
thank you, Gary, for your pound of flesh. We appreciate it.
Thank you so much.
Yeah. So obviously, it's like others have said, it's built my career. I'm older than people think.
It's the haircut, man. You got a haircut and you look, you look 10 years younger, Gary.
But people cannot keep up with you. Much younger people cannot keep up with you while biking, I've heard.
Yeah. So I once had a startup where I took everybody, on a bike ride to lunch, and I go, what's the problem? I couldn't get up the hill. I got some of them into a better habit of exercising, so that was good. But I don't know, but clearly it's made my field. Like I say, I'm older than most people in tech, and I could easily be most people's father or grandfather, even.
Well, I mean, hell, at this point, I'm older than most people in tech.
Son, but in any case, with
you're not even my real dad, Gary.
Yeah. I could have retired more than a decade ago, but so many opportunities keep coming that I haven't been able to. So, and so, I've decided to focus more on the foundation because it's always been my second job. I've been running startups and whatever. So I'm trying to come up with ideas and focus, and we're working on new deep net kind of things, experimenting with them, and potentially considering developing open data sets that I feel are needed but lacking in AI. So that's some of the higher goals. If you guys step up to the contributions, we'll be able to fund some of that. But I'm kind of funding that as I can.
So Gary, are you able to talk a little bit about the Gaussian splatting, infrastructure that are in the works? We don't know whether we'll have it,
yeah, sure.
As part of the campaign, or talk a little bit about that, because we just briefly spoke about it earlier. So it'd be great to hear it from the horse's mouth, as it were.
Yeah. So I've been thinking about ideas of where to take OpenCV and make it more central to the AI. I call it the AI conversation, right? There's many big players, and I'm working on this in the background in many ways, some of which I'm not not ready to disclose, partly because it's too early. Not from a secrecy point of view, but just like many things might not happen. I've done many startups, and this is similar. So, a lot of stuff doesn't work or doesn't happen, or you don't get that agreement, or people are misaligned or something. But what we are doing is, one of my ideas is to get very good 3D capture into OpenCV, the library. And so, and the reason for this is then we could potentially start crowdsourcing, get a phone app and start crowdsourcing the collection of 3D and radiant scenes and objects. And the reason for doing this is that AI has been developed essentially on Feifei's ImageNet, which was a great start, but it's 2D, and 2D images have two sources of bias. One is that people who take pictures tend to frame them in a characteristic way. And this causes a lot of models to fail when you get uncharacteristic poses. But also any 2D view of a 3D world is variant. And, when the world is a 3D structure, so a car looks different from every single angle, but the 3D structure of the car doesn't change, right? And so, we would like to start a collection of 3D data I have a potential handshake deal with the cloud provider that has the cheapest rates in the industry. And so there'd be all this data that you can train new foundational models on, test them, because you can, with let's call it a neural model, but Gaussian splatting is the latest and greatest. with a neural model, you can algorithmically generate random views and scales, and so you can get like infinite data from a whole bunch of objects that's unbiased. And this is what we're trying to do. So where I'm focusing is on being able to capture the 3D structure of a scene. This is typically done with ColeMap algorithm, and ColeMap is a slow algorithm that's dense, kind of odometry. It works quite well, and then people move to Gaussian splatting and NeRFs. If you've been through the literature, NeRFs are kind of a deep net that learns the voxels of space and how they color light, and so it can reproduce the objects within it, because the deep net can infer where rays of light come from, color them, and you get an image. With Gaussian splatting, but of course you've got this huge network that's representing this volumetric data, and so Gaussian splatting is the next smarter thing to do, in that it represents as a basis function the surfaces with Gaussians that are colored. Now, this isn't the end story, because the Gaussians aren't yet textured. But you can nest a lot of data about the surfaces. Eventually the surfaces will go to semantics. So this would be research work. But what we want to do is get a faster tracking algorithm. And so we're looking at some state-of-the-art SLAM algorithms, deep SLAM algorithms, and seeing if we can use those and still get high quality maps. Now, right now we can't. Working with some interns, nothing was working at first, but I suggested, well, this is a bug, and teaching them how to debug this, and sure enough, they found a bug. And so at least with ColeMap, we're getting now beautiful 3D objects. Now I'm trying to, let's sparsify the ColeMap and get that working, and then use these sparse tracking algorithms. That's kind of the progress. I hope to have this, but I might also collaborate with like NeRF Studio and these other people. Like, what we really want is just an easy way of capture, and have that available, and then encourage capture to a public data set. Now, this data set we would use to improve models, but we'd open it up to at this point, that will be a membership in OpenCV, and you'll get the cheapest GPUs that you can get on a cloud. That will be a partnership with another company that we're talking with, and there'll be a whole collection of data for training models, testing models, and hopefully returning something to the user. So doing some kind of generative scenes with these models. This is all forward-looking stuff that has not
Still really
happened.
interesting. Still really interesting to hear about, and I'm sure for the folks at home. We are going to take a 10-minute break here, and I'm going to put on a film strip called How the Eye Functions from the Rick Prelinger Archive at the Internet Archive. All glory to the Internet Archive. We'll be back in about 10 minutes after we take a little break here, get some water, maybe go to the bathroom, whatever. Thanks so much for joining us, folks, and we'll resume in about 10.
Okay. All right. We'll also play, Gary has a short video about Stanley. I think it's a minute-long video. At some point, we'll play that as well.
Yeah, we'll definitely do that. Yeah. All right, I'm going to hit play here.
Right now, at this very moment, as you watch these light rays striking the magnified eye, similar tiny beams of light are entering your own eyes. And it's by our eyes that we are able to gain a great part of our knowledge. Nature has located the eye close to the brain so that its messages may arrive there quickly. Nature has also provided ample protection for this very delicate organ. Here, with the outer coverings removed, we see the eyeball completely surrounded by a layer of soft, fatty tissue and placed within the bony orbit, where it lies protected against sudden jolts. Seen from the side, the protected position of the eyeball within its funnel-shaped eye socket is shown still more clearly. Once again, we see the fatty cushion which protects it on all sides. Note this white stalk, which is the optic nerve, and also these muscles, which move the eyeball. This is the empty eye socket within the skull, with its bony walls inside and the rim of the bony orbit in front. By gradually restoring the outer portions of the skull and also the covering tissues, we can now realize the location of the entire eye in relation to the outline of the face. Another important safeguard to the eye is the tear gland, which secretes the tear fluid. This is an effective germicide which drains through the tear ducts into the nose after flushing and cleaning the entire eye surface. The eyeball itself has a white, glistening surface. Its front part bulges and forms a highly transparent window. In this sectional view, the capsule of the eyeball is seen to have 3 layers. This thick, tough outer layer is called the sclera and serves to protect the delicate structures within. This transparent bulging portion is called the cornea. Notice also the crystalline lens, which is one of the main features of the eye mechanism. The second layer is called the choroid. It consists of 3 different belts or zones. The first zone is called the choroid proper and is the part that carries nourishment to the tissues of the eye. The next zone is called the ciliary body. This is a broad ring-shaped band of thin muscle fibers which play a very active and vital part in the visual adjustment of the eye. The third zone is the well-known iris, which expands and contracts the pupil much like the diaphragm of a camera. The iris will soon be described in greater detail. Here is an outside view of the entire choroid, which shows the dense network of arteries and veins carrying nourishment to the eyeball. You can also see the shape of the ciliary body and the iris. The innermost layer of the eyeball is the retina, a very delicate membrane. The retina is actually a part of the optic nerve which transmits the light impulses to our brain. The retina is the most important and complex structure in the eyeball. Magnified many hundred times, the retina is seen to consist of this complicated arrangement of rods and cones, which convert light waves into nerve impulses in some manner which even science of today cannot fully explain. Between the lens and the cornea is the aqueous humor, consisting mostly of water and a little salt. This larger space within the eye is filled with the vitreous humor or body, consisting chiefly of water with some salt and albumin. The vitreous humor is really a highly transparent jelly and plays a very important part in the act of visual adjustment. Thus, light rays entering the eye must pass in succession through first the cornea, second the aqueous humor, third the pupil, fourth the crystalline lens, and fifth the vitreous humor in order to reach their destination, the retina. Now, just how do light rays act to form a clear picture within the eye? First, let us realize that light rays reflected from any object radiate in all directions, and that as an object moves farther away from us, the angle between the rays that enter our eyes grows smaller and smaller. And finally, when the object has reached a distance of 15 feet or more, the rays entering our eyes are practically parallel. Now, nature has provided that parallel rays shall produce a sharp image upon the retina without any effort, and, as one may say, with the eye in a state of complete relaxation. But if a distant object approaches the eye, the angle between entering rays again grows larger. This increasing angle changes the direction of the light rays as they pass through the lens, so that the sharp image falls behind the retina. As a result, the image upon the retina tends to become blurred. This blurring causes a response or reflex within our brain, which brings about harmonious internal adjustments of all parts of the eye. This adjustment is called accommodation. Accommodation restores the sharply focused image with marvelous speed and accuracy. This is all the more remarkable because the distance between lens and retina is fixed, and the lens itself must change its shape. Now compare this with the focal adjustment of a camera. Here the lens remains unchanged, but the film itself is moved until it reaches a sharp focal image. It is also necessary that both our eyes be fixed upon the same point in order that we may see an object clearly. Thus, as an object approaches us from a distance, our eyeballs turn accordingly. This movement is called the convergence of visual axes. This action is shown here as the object approaches and recedes. Here, in addition, we see the lenses accommodating their optical shape under the combined influence of blurred image and eyeball movement. And now let us look at this highly enlarged view of the lens itself. It has a soft, yielding body and is as transparent as glass. But it also has a firm, ball-shaped central core or nucleus. It is contained within a thin, elastic membrane and is suspended all around by a spoke-like arrangement of delicate threads or ligaments. The lens itself lies between two liquids. These liquids can exert pressure. All liquids cannot be compressed. You may ask then, how is this soft, pliable body of the lens made to take on the different degrees of convexity necessary for accommodation? In order to explain this, let us again call attention to the important ciliary muscle, which we see here in the diagram. This muscle is shaped like a broad ring which can expand and contract. Whenever it does contract, it must press upon the non-elastic vitreous humor. This liquid is confined within the rigid capsule of the eyeball and must, therefore, exert pressure upon the lens. Now, the lens as a whole cannot give way against the equally non-elastic aqueous humor and its confining cornea. So the only part which can possibly yield to the pressure of the vitreous humor, or body, is the soft substance of the lens. This lens substance is thus molded into an even curve against the rigid ball-shaped core, thus forming this highly convex bulge, which science has called lenticonus. So whenever the image upon the retina becomes blurred, the brain automatically causes the ciliary muscle to contract or to relax until the lens has attained just the right shape to restore a sharply defined image upon the retina. This is the remaining portion of the choroid, called the iris, with its central opening, the pupil. Like the diaphragm of a camera, the iris regulates the amount of light and sharpens the image upon the retina. The iris acts automatically, and so is an important link in the process of accommodation. Its action is caused by two sets of delicate muscle fibers within the iris itself. These muscles are shown here in simplified diagram. These spoke-like radial fibers pull the pupil open. This ring-shaped muscle around the pupil closes it. In this side view, we see the opening and closing of the pupil, so that we may more clearly understand another important part played by the iris. Whenever demanded by conditions, the lens acquires this peculiar bulge called lenticonus. This cone-shaped curve at first causes light rays to become distorted into aberrations upon the retina. As a result of these distortions, the pupil now contracts until the diffused rays have been shut away and only a clear image remains upon the retina. These interesting mechanics of the lens are not generally known, and the facts presented here have only recently been accepted by science. It is well for us to know that our eyes are one of our greatest gifts of nature and are indeed worthy of our constant care and protection.
Yes, that was How the Eye Functions, courtesy of the Prelinger Archive on the Internet Archive. That's archive.org. I don't know if you're aware of this. The Internet Archive is embroiled in a little bit of legal trouble from some major publishers out there for the library, the online lending library they created during the early part of the pandemic. I think it's very important to support the Internet Archive in this and everything else they do. Like OpenCV, the Internet Archive is an incredible resource for free access to knowledge that absolutely changed my life, and I know a lot of other people. It made it possible for me to see so many amazing things that I would not have otherwise, such as, for example, that short film, How the Eye Functions. Our next guest is about ready to join us here. Let me see, where is... There he is. All right, I just sent him in there. Please let me know if you all liked that short. I've been thinking about working more of those old educational shorts into the OpenCV shows we do. That we'll soon start doing every week again. And we appreciate you for joining us, no matter how often you join us. Ramon.
Phil, my friend, how are you?
I am doing great. I'm hanging in there. I'm hanging in there. Ramon, what you want to go ahead and tell the folks who you are?
Hey, I'm Ramon Roche. I'm the general manager for the Drone Code Foundation. Drone Code Foundation hosts a few open source robotics projects such as PX4 Autopilot and the Pixel Open Hardware project.
Yes, and we were just in the great city of New Orleans for the PX4 Developer Summit. You want to talk a little bit about how amazing that was?
Yeah, thanks, Phil. And by the way, thanks everyone for supporting OpenCV. I'm assuming everyone already donated. Please see if you haven't. This is the time for you to go and click.
If not, snap to it.
Yeah, what are you waiting for? So yeah, Phil, we hosted our yearly event in New Orleans. That was a bit more than a week ago. It's hard to believe, but we had an amazing weekend. We hosted the event just after ROSCON. So we were in New Orleans for ROSCON. We stayed over the weekend for the PX Developer Summit in New Orleans. We had a blast. We had more than 200 people join us. A lot of people from ROSCON stayed over the weekend, and a lot of people from our community migrated to ROSCON, so they came in early. I want to thank OpenCV for sponsoring the event and for being there. Hi, Satya. Yeah, I had an amazing time. I think I learned a lot of things about New Orleans while we were there.
Yeah,
I learned a lot of things and forgot a lot of things while I was in New Orleans. I think that's the correct way to experience it.
Exactly.
Shout out to, I think Corey was his name, our bartender at the Saint. If you're ever in New Orleans, go to the Saint. It's what you might call a 7 p.m. to 7 a.m. bar.
So many.
Yeah, Satya, you want to talk a little bit about our experience at the Drone Code Summit?
Oh, it was really good. You know, first of all, this was the first time we went to any drone conference, right? And it was really well organized, and the speakers were great. I also, I feel that was when I felt, when I went there, I felt that this is one of the areas that are going to take off in a very big way, right? So you don't realize, you always know that, okay, drones are around, and they are going to be mainstream. But when you are in the conference, you see so many companies, so many ideas being put together, And you feel that, I mean, I really felt that, okay, it is on a cusp, a technology which is on the cusp of an explosive rise, right? So that was my biggest takeaway from that event. Right now, drones are, I think, used mostly, right now, the main use of drones, right? It's for kind of entertainment kind of thing, right? You're playing with drones and you're doing, but very soon we are going to have drones become, for delivery, we are going to use it. We are going to use for crop monitoring. We are going to use for all the places where, where a man on a helicopter, there was this meme, right? A man on a helicopter trying to take some footage. And they said that, look, drones actually, after after drones came into being, the man as well as the helicopter pilot, they lost their jobs, right? And which
won't somebody think of the poor helicopters?
It's a way more cost efficient delivery and transportation, like service oriented technology.
Yeah, and the application areas are just huge, right? There are some very difficult areas, for example, monitoring windmills, these kinds of things, where drones are the right solution, right? It's very difficult. It's really bad idea to have people go there and take footage of that kind of installation. And their drones are the right solution. For a lot of places, drones are the right solution. And that I learned, it really opened my eyes, the conference. So highly recommend people. I think you always do it with Roscon. So people who are...
It was the first time we did it with Roscon. We're looking to see if we can do it again. Hopefully we can.
Yeah,
that's right. We're calling OpenCV, PX4, and ROS, the open source triad, Hove, if you will, the diamond cutter, all that stuff.
Thanks, Phil. Yeah, so you put it right, Satya. Like, I think we've been hosting this event for the last 5 years, and this year we felt like there were so many new things that we weren't really aware of on our immediate radar. So we keep on running public weekly calls, and like we go through the development process and phases, and you continue to work with more partners each day. But at the summit, we really met a lot of people that weren't in our immediate network, that were finding value in PX4 and finding value in ROS, finding value in OpenCV. Like, turns out that, like you're saying, drones right now, the majority of volume is being used for entertainment. But there's a lot of companies that are already using drones as tools, precision tools for measurement, precision tools for mapping, precision tools for delivery. And that's really what we're here for. Like, this open source project, just as OpenCV, is no longer for like the enthusiasts and just for tinkering in your lab. Although, like, who doesn't have fun doing that, right? But the reality of things is that aerial robotics and robotics in general are becoming like very common in the day-to-day, and they will only continue to increase the frequency you see and interact with them. So picture the future of autonomy, of vehicles on the air, delivering your packages. Like Walmart is already doing this, like right now, in fact, using PX4. And the reality of things, like first Phil was saying, is that we need the open robotics trifecta. You need to be able to see, like, all these drones. Like, yeah, we have tremendous navigation and estimation capabilities, but you need better and more sensors all of the time. So we had first benefited a lot from the iPhone revolution and like smartphone, and like getting all those sensors cheap was really good. But now we're going a bit backwards. We're not backwards. We're a different way of seeing things, where the actual manufacturers of those sensors are looking into robotics and like first doing a robotics first sensor and then commoditizing for the rest of the technologies. So they're looking at us for like the cutting edge technology that are actually moving things forward. And that is really cool. And that is really interesting to see. So if anyone here is like interested in working with drones, please feel free to go to px4.io. The project website is px4. You'll find a link to Discord where we all hang out. There's links to the calendar where you can see all the schedules for the public calls. We have a Q&A call, we have a maintainers call, we have more in-depth work group calls. So if you want to encourage, I want to encourage everyone to join all of those things, because that's what we're here for. Like, that's what we're running every day from like 8 till 10 a.m. That's what I am doing, running those calls. But yeah, so thank you again for coming to the summit in New Orleans. It was an amazing time. Oh yeah, before I forget, Drone is now a bronze member of OpenCV.
Yes.
So yeah, I wanted to, thank you as well for the partnership, and we want to continue working together. Yeah, de nada, Phil. We want to create more educational content, so hopefully together we can partner up for more tutorials on robotics and OpenCV. That would be really interesting. So if anyone in the chat here has any questions about anything drone related, please feel free to drop them now.
Yes,
and by the way, again, remember to donate.
Yes, please, please donate. Yes, Ramon, in your honor, I'm cracking open a Modelo. It's 2 o'clock in Michigan. That means it's 5 o'clock somewhere.
It's 5 o'clock
so
somewhere.
See if we can get to that ASMR.
Salud.
How's that? Is that nice?
Oh, I'm gonna put the link on here. It's px4.io.
Yes, that's PX4 Autopilot.
That's
yes,
right.
we are. I haven't done a promo for Chuck's shop yet, so I'm going to do a quick one here. If you're anything like me, you are a huge sucker for notebooks. I've always got at least one on me at any given time. I'm a big fan of the Field Notes brand. This one is the heavy duty edition. It's got a nice thick cover on there. It's got a ruler on the back. And they have the full line of Field Notes books here available at On-Base Productions, such as the Snowy Evening edition, foiled again, this beautiful foil stamped edition, and even the Dungeons and Dragons Dungeon Master, Monster Encounter, and Campaign Journal editions. And you can check those out at onbase.store. Shipping US only, is that true? No? Well, they ship globally apparently. So check out onbase.store and buy you some notebooks. Show a little love to our gracious hosts here. He is my brother, but he does not have to do this.
Thank you. Thank you.
So yes,
yeah, so one of the questions from Tiana is that, if drone is becoming more important, does OpenCV take into account applications for low power? So OpenCV from the very beginning, it's all about efficiency, right? It is it's a very efficient library. So even when we implemented the deep learning module, DNN module, in that case, our C++ implementation in the beginning was, I think, 3 or 4 times faster than what you could get using PyTorch or TensorFlow. And now things have caught up. I don't think we have that big of a margin right now. But it's a very efficient library. So things are faster, they work on low power devices, etc. In fact, 89% of embedded vision engineers use OpenCV as the primary library. And they may not use the OpenCV library completely directly, right? They would use algorithms, optimizations from the library and incorporate them in their embedded devices, right? So yeah, it is a very important piece for us because OpenCV is an optimized library. It was one of the core principles that it would be optimized for various platforms.
And we're planning to improve that significantly with OpenCV 5, as we've talked about before. Many of the optimizations in OpenCV since the beginning have been more geared toward Intel hardware and chipsets, but we're trying to make that more equitable across the board. And that is an important part of why it's important for you out there watching to donate. And if you've already donated, share the link with your social networks, with your bosses, with your cats and dogs, your spouses, your children. Share it everywhere and let people know why you think it's important to support OpenCV with their hard-earned money. I know it's not easy out there, it never is, but I think for everybody watching this, it would be a lot harder without OpenCV, and that's why it's important to keep it going.
Right.
So yes, Ramon, if people want to find you on the internet, what's the best way to do that?
If they want to find me specifically, they can do it on Twitter. Well, X, previously known as Twitter. My
We're just saying
username
Twitter
is
on here. We're not going to feed into that guy's ego. It's Twitter in this house.
That's crazy. I just told my team the same thing. They were like, "Let's do the X thing now." Like, no.
Absolutely
So
not.
you can find me at Mr. Pollo, MRPOLLO. That's my nickname since I was a kid. So I just use it everywhere. Also in GitHub, if you want to find me, it's the same username. And in LinkedIn, since I have to be professional, I'm going by my name in there. So do Ramon Roche. It's the same if you're looking.
Roche.
Yeah, it's ROCHE. Feel free to send an invite. I would love to discuss anything that you would like to do on robotics, aero robotics specifically, or any type of robotics. Happy to help you. And before I let you go, I just want to say, please, everyone watching, please donate. Don't take your open source projects for granted. We're here. Most of us are volunteers. Most of us are operating under very thin margins, and we're here to help you. We do this because we want to do it, because we feel this is the best use of our time. And I think that we have something really successful going on with OpenCV. Let's help them keep it going. Thank you again, Phil. Thank you, Dr. Satya.
Yeah.
And thank you, Gary. It was lovely to be here. And thank you, everyone. Goodbye.
Yeah, thanks, Ramon. Before you go there, Ramon, real quick, got to give a huge shout out and much love to the Linux Foundation live events team. Holy moly! Can you give them a quick shout out by name here, because holy smokes.
Yeah, definitely. So first of all, thank you to Emily, Jennifer, Allison, Ashley, Rachel, and Angela, all of which helped us make the event in New Orleans a success. It's stress-free, literally from the moment we started planning to the last minute of the after party. Like, we didn't have to worry about anything. It ran smoothly. And thank you, Phil, for bringing that up.
Yep. Sometimes I just got to do your job for you, I guess.
Thank you. That's why you're the man.
You are, in fact, the man. El hombre. Our next guest will be Kwabena Aguiman in about 10 minutes. So I think Satya, Ramon, thank you so much. Adios. Let's talk about a couple more features of OpenCV 5, Satya.
Can we, I was wondering whether we should do the Stanley first. We should show that video by Gary.
Let me go ahead and pull it up.
Yeah. And then we'll go over the features.
Sounds great.
One question while Phil is pulling it up by Shashank is, what is the difference between TensorFlow and OpenCV? So OpenCV is a computer vision library, and TensorFlow is a deep learning framework. Now, deep learning is a specific part of machine learning, which basically implements deep neural networks, right? So there are a lot of problems that in computer vision that can be solved using deep neural networks. And for those problems, deep learning is great. And TensorFlow, you can use, you can use TensorFlow to train the model as well as do inference. In OpenCV, we also have a deep neural network module, which is only for inference, which means that once you have trained the model, you can run it inside OpenCV, but you cannot train the model using OpenCV, because we saw that, okay, PyTorch and TensorFlow are doing a great job. We don't need to implement those training frameworks. So we implemented only the inference one. Now, deep learning or even machine learning is only a part of computer vision. It is not entire computer vision, right? So there are parts of computer vision that have nothing to do with data, right? So you don't need a lot of data to solve problems. For example, if you want to do image enhancement, you don't necessarily need a lot of data. If you want to do camera calibration, it's a geometry problem that you want to solve. So it doesn't require a lot of data. Similarly, stitching panoramas doesn't require a lot of data, right? You just take the images and you stitch them using some geometric constraints. So there are 2,500 different algorithms that are implemented in OpenCV that you will not find in any other library, right? And these are specific to computer vision, right? All traditional computer vision algorithms as well as deep learning algorithms. So it is true that many state-of-the-art algorithms in computer vision are powered by deep learning, right? For example, image classification, object detection, segmentation
All of those things have the state-of-the-art algorithms are based on deep learning. But then there are, half of computer vision, or at least 40% of the computer vision has nothing to do with deep learning. For those things, all the 3D stuff, you will need OpenCV for, right? So I feel that, if you want to have a career in computer vision and AI, you need to have expertise in both of these things. You need to have expertise in OpenCV, which is the computer vision part, and you need to have expertise in one of the two top frameworks, either TensorFlow or PyTorch. So that's what you need for a career in computer vision and AI. Okay, so
Great
are we
answer,
ready for?
Satya. So let's, I got Stanley right here. Let me pull it up and share. All right.
This is an overview of the 2005 DARPA Grand Challenge race across the desert. Carnegie Mellon's Highlander started the race. The race was based only on running time, so the starts were staggered. Next we have Stanford's car Stanley beginning the race. Stanley pulls out in front of the crowd and then takes off into the desert. Here it's coming, doing a sharp turn and coming back. This shows the map in which officials and the crowd were able to track the car's progress in the race. Next we see where Stanley passed Highlander. We'll come up and we'll see now the LiDAR view. The cars were racing strictly on time, but Highlander was getting in Stanley's way, so they stopped it and let Stanley pass. Next we're showing Stanley coming down the mountain pass. We'll speed this up. This is where the GPS was inaccurate, so if you followed the GPS exactly, you'd go off the cliff. But Stanley's using vision, so it corrected to the road. After the mountain, Stanley crossed the plain, and this is the sequence of coming into the finish line. You can see Stanley driving up to the crowd, and that's the winning of the 2005 DARPA Grand Challenge, which set off the autonomous driving industry. Stanley can now be found in the Smithsonian Air and Space Museum. And this is the Stanford team that created Stanley, many of whom have gone on either to Waymo or careers all over the world.
That's excellent. Is Gary around? Gary, are you around? I don't know whether he rejoined.
Awesome.
Yeah, I am.
History there.
Okay.
Hey, Gary, welcome back.
So yeah, we just played the Stanley video. Who other recognizable people were part of the team? Was Dr. Andrew Ng part of that team, or Sebastian Thurn?
He wasn't. That Sebastian Thurn, Mike Montemarillo was the team lead, and they were the two standing up at the end image. What's his name? Tony. The guy at the finish line was the head of DARPA at the time. Tony, I can't remember his name. Anyhow, there are many people on that team, which if you focused in, they went all over the place. Like the CTO of Khosla Ventures was, on the team, Sven. And on and on. The many people are on the team from all over, done companies and other things, but a whole chunk of the team had joined Google, and some are still part of Waymo.
Awesome. And correct me if I'm wrong. Most people were expecting from Carnegie Mellon, there were two entries. They were, I think, called the Red Team, as far as I remember.
Yep.
And most people expected one of the two vehicles to actually win the competition. They were very well-funded Carnegie Mellon teams.
Yes.
And they also had these large vehicles, which had a lot of sensors, and they were loaded with different things, right?
Well, the CMU team, though they corrected these rules later, Red Whitaker was taking advantage, not cheating, but like a competitor reading the rules and leveraging the rules as much as possible. And they had these vans of clickers. So the problem with GPS is they're not accurate enough to drive across the desert. So what they had was a whole bunch of people, and so early in the morning, we got a CD, with the race course. So we didn't know what the course was across the desert. We knew the general region as we got there. They said it's going to be in this region. But it's only in the morning of we got a disk, and I forget what the time was. You had like an hour to install the disk in your car and pull it up to the starting line and then start. So we got the disk, put it in, and that's it. Our car was running. The GPS waypoints were guidelines, and the vision and the LiDAR were the exact finding. But CMU had this bus of correctors, and so they had accurate maps of the whole region, and they simply corrected the waypoints for where they had measured on all the roads in the region that you get the true signal. And so by the end, I could see the Boss was the car that they'd won. Its LiDAR had failed, so it had what we call this LiDAR that could see really ahead, scanning. But we could see it failed. I called it the Eye of Sauron, but it had slumped and died. And I knew their camera wasn't really working.
Lidless and wreathed in flame.
Yeah, so the car got there on the waypoints, and still, they did a huge job getting this done, and it technically, fulfilled the military specs of being able to operate autonomously in a region, but it wasn't quite the spirit of the law of the race. And but we did it by the spirit of the race, and we won. That
was excellent. And this was did the Carnegie Mellon team also use vision extensively as much as the Stanley team, or
no? I don't think they were really using it. I think I'd asked one of them, and it wasn't really part of the navigation. I can't swear to that because I wasn't on the team and it's a long time ago. But I think I asked them, there was this Lewandowski had his motorcycle that they let him in the starting line, but I had talked to him the day before and I thought the whole thing was just a sham because, I had touched the camera. They used a industrial stereo camera, and I touched it saying, oh, that's smart, because the cameras we used had fallen apart, the stereo cameras, and this was the Cognex machine vision camera for the factory, already in like a sealed case. But when I touched it, it fell off the motorcycle because it was Velcroed on. I go, you cannot Velcro on a sensor and expect its calibration, So I go, you're not really using this. And he goes, oh, the guy forgot to turn in his code. And I go, well, actually, we had locked down the code 3 months ago, and simply we're doing reliability testing. What do you mean the night before some guy didn't check in code? It's crazy. So I knew that it wasn't a real entry, and it fell over. But I think he didn't turn on supposedly he didn't turn on the gyroscope. I think that was on purpose because it just went whoop plump. Oh, big disaster, like you forgot to tie your shoes in the Olympic, trials, or you intentionally didn't, so it would seem like a big tragedy. You tripped on the Olympic trials because you forgot to tie your shoes. Oh, tragedy. No, it's like you weren't working out, you were drinking beer, and now you didn't tie your shoes.
Who amongst us hasn't tripped at the starting line?
So some people may not be following the thread. Let me just because it's all the things that you're saying is quite scandalous, and so it's
yeah. Well, maybe I shouldn't say them. I don't know.
Okay, so the DARPA Grand Challenge, right? The challenge was to drive 132 miles through the Mojave Desert. And as Gary mentioned that, the path was not fixed at that time. They would give you the path right at the beginning of the race. And the year before, there was no car that actually completed the race. I think the longest.
Yeah, this was the second running of the race.
Yeah, in 2004, the longest one was, I think, 8 miles. It went up to 8 miles and then it stopped, right? So this was
it ran into a fence post and got stuck on it.
Right. So in 2005, people were much more prepared, and there were two, CMU team as well as the Stanley team. They were, pretty highly regarded, which is great. But there were also several other teams that had competed. Many of them were legitimate, but there was one entry which was a motorcycle. It was not even a car, and this motorcycle entry was by a guy named Lewandowski. And this Lewandowski guy, I mean, what Gary is saying is that basically it was a non-working model and it never went anywhere. It in fact crashed in the first minute of the race, right? Right after it started, crashed. So an interesting story about Lewandowski
sort of like a cruise taxi with a cone on it.
In the end, I think there were only 5 entries because they whittled it down. I think in the beginning there were 500 entries, and then as you had milestones, they shrunk it down. The motorcycle was eliminated in the days before when they were doing, test races and test timing, and it simply just fell over. Right?
It went couldn't like stay vertical.
Right.
Yeah.
But there's more to the story, right? So Lewandowski goes and joins Google. He's actually a smart guy, right? He's not. He's smart guy, but also,
To interrupt you briefly, Satya, this eagle-eyed viewers and eagle-eared viewers will remember some of this story from the OpenCV AI game show. Go on, Satya.
Exactly. So Lewandowski went to Google and he worked there, and then he left Google for Uber, and apparently stole some secrets. In fact, it was proven that he stole some secrets because Google sued Uber, and then Lewandowski was supposed to go to jail, right? He was convicted and he was supposed to go to jail. And guess who actually overturns the conviction? Trump pardons him on the very last day of his office, and Lewandowski doesn't spend any time in jail. So that's computer vision and AI gossip for you.
As if you needed more proof that he's not a good dude.
Well, I'm just kind of shocked. Like I could do whatever I want, but the president doesn't have my name and is not going to pardon me now. Where did he use that money to buy influence? I don't get it. Why Trump was motivated.
It's not as though the former president is an expensive date, if you know what I mean.
Yeah, I wonder if some money went, if you could uncover some of that money, how did it happen? But anyhow.
Yeah, well, let's somebody get CoffeeZilla on that. We've got another guest coming here, who's being patient, waiting for us. I'm going to invite Kwabena Agyeman to join as a panelist here, the founder of OpenMV. I think OpenMV and OpenCV have a whole lot in common, and we're really happy to have OpenMV as part of this big OpenCV campaign. Kwabena, welcome, and please tell people who you are.
Howdy, good to see y'all. Thanks for inviting me on. So what is OpenMV? You might have heard of us. Basically, we've been creating an OpenCV software ecosystem with strong driver support for microcontrollers, because I think there was one of these old Stack Overflow posts where someone posted, "Can I put OpenCV on my MCU?" And the answer was no. But in the Stack Overflow mean way, where it's no, here are the reasons why, and it'll never happen. And so more or less about 7 or 8 years ago, honestly now, I was bored at my job. I was working at a big let's say Oracle.
Super
and so
relatable.
4 p.m. people jumped out the windows and left. So you had plenty of time after work when I was just got out of school, and I started working on this concept. And about 8 years in now, we sell a product called the OpenMV Cam. Basically, it shows off how do you do computer vision operations, but on a microcontroller. And so it's very similar to OpenCV. All the stuff with, we're kind of a bit lower level. Mostly it's focused on the image processing library in OpenCV. So, morph kernels, adaptive thresholding, blob detection, all of that, but we're running it on a bare metal system with no operating system. And one of the big things we had to focus on for ourselves was super high optimization of the algorithms for memory efficiency. What this means is like OpenCV might have an adaptive thresholding algorithm that you run as a secondary step after you perform an image convolution kernel or et cetera. And so we pack those operations together so that you can avoid temporary buffers. Because we're talking about computer vision on a system that might have 512 kilobytes of RAM. So we're not even talking a megabyte of RAM to play with.
Right.
And so you got to be careful about how you utilize things then in those cases.
Yeah, that's great. So as I said before, OpenMV is a part of this campaign, which hopefully everybody watching right now has already donated to or is going to donate to soon. Will be there's a tier at which they can get a piece of OpenMV hardware. Quab, could you tell us a little bit about the new module?
Yeah, so this is the OpenMV Cam RT1060. For all you old folks out there, this is basically a Pentium 3 computer that could run Windows 98. Actually, it has the minimum specs to run Windows XP, but
Wow.
now it is in a tiny board this big. So we upgraded a little bit from 512 kilobytes. Now you've got about 32 megabytes of RAM. This still means you need to be careful.
Just a bit of an upgrade. Just
a bit of an upgrade. The performance on the SDRAM though is different than the internal SRAM, so you still want to have smaller resolution images, just because doing large resolution stuff will still be super slow. But you can take pictures basically. But then the biggest part is that it comes with a 5 megapixel camera, so similar to the original Raspberry Pi camera. It's actually exactly the same. And then we also added a bunch of nice features though. Let me see if my camera is going to unblur this. Got one of these Microsoft HD cameras. It has autofocus, but I'm not sure when it's going to kick in.
Yeah, it's a little bit of mystery. It's all Saints Day.
Too close.
It's spooky.
Well, maybe I can zoom out a little bit. Anyway, no, but one of the nice features we added was Ethernet and Wi-Fi on board. So we use something called MicroPython, which has become a pretty popular basically like an operating system for microcontrollers, but bare metal. And so this gives you all the features to kind of be able to do network connectivity, so you can open up sockets and such and send data. We actually have a RTSP video streamer working on it. And cool enough, you know how OpenCV can automatically connect to RTSP stream. You can actually have this streaming RTSP video, and you can actually connect that to OpenCV if you wanted and stream video directly from it. Similarly, you can do like an MJPEG video server and stream, so it could actually be used as a camera that's remote. One of the great features though on this particular model is we added battery charging, so you can actually attach a little.
That's great. On board.
Yeah, I don't have a LiPo on my desk right now, but let me actually hold on. Give me a second.
Yeah, I just dropped the link
hardware
to
studio
the,
behind me. You can actually add like a little LiPo like this, right? And plug it in. And that'll let you kind of basically be able to run this system off a battery.
Nice.
And one of the bigger things we added is super low power current consumption when in sleep mode. So what you can do is you can actually hook up, for example, like a PIR motion shield on top of it. And so this has IR LEDs.
And passive infrared for folks who didn't get the acronym there.
Yeah. So imagine, let's say you wanted to build a little system that acts as a security camera. So this thing can actually go into an ultra low power mode where it draws 30 microamperes. So 30 microamperes, if you know anything about electronics, with a 1 amp hour battery, that is 5 years of battery life while it's sleeping. So that means you can actually make this thing into a camera where it sits there sleeping, you walk by it, it turns on, turns its lights on, takes a picture, goes back to sleep. And so that's the application you could build with one of these devices, and it could actually be on a battery in a case and run for literally years. And then because of the Wi-Fi Bluetooth connectivity, for example, you can make a Bluetooth phone app, have some config settings there if you want to change its behavior, or you can actually send that Wi-Fi data and then upload the image to the cloud and then have it turned back off and such. So our product's more like a really focused way of combining computer vision with tight drivers and then the processing software on board in one nice package, so you don't have to fight all the demons of hardware design and such. You can just kind of skip to the application, the features I need are put in there, and I don't have to like rebuild everything.
Well, yeah, you got to limit the number of demons you're fighting at any given time. You know, it's very important.
So, Satya, what's the tightest amount of memory you've had to work in? Tell me about some of the hardest optimization challenges you had to do for your.
That's a really good question.
Yeah. So to be honest, we have not worked on a microcontroller, level application. But actually we have, but I have not, right? So with OpenCV.ai, which is the consulting arm of OpenCV, and I did not lead the project, so I don't know the details of it. But the requirement there was that we had to do an object detection, right? So they also had a thermal camera in the scene, right? So basically they wanted to know the occupancy of a room, right? How many people of a meeting room. And this thing had to run on a single charge for 2 years. Yeah, and so, all these tricks were used. I, unfortunately, was not part of that application, but the idea was that you would use, there was a thermal sensor involved, and we had to use a very small, platform, and it had to last for 2 years. So Anna should be able to talk about it more. Who's the
now? I want to pose the same question to Gary. I wonder, Gary, what's the smallest amount of memory you've had to work with on a project?
I mean, I told you, you could all be my grandchildren. I'm older than you.
I'm telling you, Gary,
my first PC.
Stay away from my mom.
My first PC had 12 megabyte hard disk, and I thought, how can anybody ever use that up? It seemed like the vast open plains. Like this will never be. I can play here my whole life in these 12 megabytes, and now that's one picture. So I don't quite remember, but I'm early on. I had these little 6800 chips doing things. I mean, in essence, like these microcontrollers are perhaps even smaller than some of the things we had, because they didn't have those are pretty big chips. They burnt a lot of energy relative to the chips today. But I did a project with it was a medical project, and I remember these things called C compilers were just getting really and so I code in assembly, and every byte would had a count for things. It's funny, before I entered computer vision, I was working on a project, but it was, very primitive edge detectors. Before I had any training in it, it was just derivatives, right? And that's all I thought about, taking the derivatives of these images, and it was extremely small. I don't remember, though. I don't. Yeah.
Well, to answer your question, Satya, about thermal, one of the things you can do with OpenNVCam is the image sensors are actually swappable. And so this is an example where we've actually swapped out the sensor for a thermal sensor. And so we actually have something really nice running on board now called TensorFlow Lite for microcontrollers. We partner with a company called Edge Impulse. And so you may have heard of them. They basically let you train an ML model online. You kind of upload the pictures, push that to a cloud, and then you can then output 2 different types of models. You can either do an image classification model or a new one called FOMO, faster objects, more objects, just like YOLO. Has one of those good names. And it outputs, for example, the centroids. So unlike, so basically with YOLO, you're outputting these bounding boxes, and computing that's very prohibitive. It takes a lot of power, so you need typically a much higher end CPU. But what they're actually doing is they do a segmentation mask, where they've basically train the neural network to only light a pixel up if the class it sees in that pixel region is matching what you want. So more or less, you can take like a let's say 256 by 256 image. You shrink that down into 128 by 128. And then with the 32 megabytes of RAM on board, you can actually run the FOMO algorithm. It might only use like maybe 1 or 2 megs while it's running. And it'll basically output that image segmentation mask that says, okay, these pixels are literally the centroid of an object that I want. And that'll be like a 128 by 128 grid. And then you can upscale that. We do that internally in our image library back to the native resolution you passed. And you can then draw a centroid for all the objects. And so, for example, if you trained it on a thermal image data set of people in a room and then ran the FOMO model, you would actually be able to identify and get centroids of the people in the room. And then you can count the centroids, and then that'd very easily be a robust system to detect people in the room. And then you could actually couple that, though, with the PIR shield I mentioned. And if you did that, then you can have the thing wake up on motion, use the thermal camera to detect who's in the room, and then take those, do that FOMO model to figure out the number of people in the room, and then go back to sleep after transmitting that to the cloud. And so we sell all the hardware that you'll need to do that. And so you don't have to do any design. You can just kind of deploy it as is from buying on our store.
Excellent.
A little more details about the model architecture that, where we were constrained by space. The model size for that people detector was 600 kilobytes. And it had to be quantized to 5 bits. So and that solution lasted for 2 years on a single charge.
Oh yeah. But this is actually a very interesting field, though, because there's going to be a huge growth in terms of edge computing. Is really going to be kind of the new frontier of where a lot of folks can build out machine vision algorithms. The best way to say it is you've got 2 trends happening right now. So actually, thanks a little bit to OpenMV, we kind of showed that it was possible to do computer vision on microcontrollers. I remember when I first got started with this, we got April Tag, for example, running on a Cortex M7 with 512 kilobytes of RAM.
Oh, so nice.
The April Tag algorithm, the one that can detect those area codes, we got that running in 512 kilobytes. Wow. It was so insane that the founder of the April Institute, who's now running May Mobility, which is a self-driving car company, he invited me back when they were first getting started to come out to Michigan, actually, to say hello to the team, just because I managed to make that impressive feat possible. And so a lot of people have been thinking about, oh, hey, if that's possible, what other stuff could I do? Like, you ever heard of Juicero? It was a product that failed in the Silicon Valley.
Have I heard of Juicero?
Didn't you invest in some juice company?
Yeah. It was
no, sorry. Maybe it was not Juicero.
I didn't have nothing to do with that, but they actually used a Cortex M4 to do QR code detection, and that was because they wanted to detect the QR codes in these juice packets.
That seems like a bit of overkill.
Yeah, it was, but it was a novel idea, though, that now that I have QR code detection on the OpenMV cam, and this code has been copied because we're MIT licensed to a lot of other people's systems. It is very easy, though, to say, hey, I could do a Cortex M4, which is not exactly the most powerful CPU, and I can have that with a little cheap, like $1, inexpensive camera, and I can make a system where if I have some labeling or package I'm putting in a device, I can actually barcode scan it inside the system then for less than $10 in a bill of materials for some hardware component. And so people thinking about that, it's actually spawned these chips getting more and more powerful. And so what you're seeing now is there's new processors that are going to be coming out called the Cortex M55 later next year. And so we're talking about performance increases that are about 4x or so in the future in the microcontroller world, where we're starting to hit application level processor territory in terms of performance. And then you also are going to start seeing neural network accelerators appearing on these microcontrollers. And when those hit, you're actually going to be looking at something on the order of 2 orders of magnitude more performance. So we're talking 100x to even up to 800x faster. And once that happens, the realm of microcontrollers being a joke for doing this and an interesting thing, suddenly they're showing up to the ring, pretty much have worked out as much as Rocky and are ready to...
Turns out the microcontrollers got hands.
Yeah, yeah. Obviously, definitely still application processors will be orders of magnitude faster still, because they're going to get the same improvements. But the question is, like, what can you build in such a tiny package to deploy in low power applications? Like, let's imagine you wanted to make all the light switches in your house. If you ever heard of the brand Lutron, they do a little, IoT light switch, which is super nice. Like, what if those had cameras in them and so they could like turn on as you walk by? I know, creepy, sci-fi. Yeah. Who would want that? But the question is, like, if you could lower the price of cameras and the sensing technology to below $10 or something for deploying that, what kind of applications could that go into? Like, what new novel ideas that people don't think about right now because it would be too expensive? What does that become? What could you do?
Yeah, really, yeah. A question that there are enough answers to that are going to make some people very wealthy, I'm sure, in the coming years. Somebody's at the door over here. Gary, we lost Satya somewhere in the ether here, but Gary, I'm interested in your thoughts on some pie in the sky. Look in the future a little bit about microcontrollers and embedded apps here.
I mean, obviously there'll be more and more in our life for monitoring, all kinds of stuff, from simple monitoring, whether, dogs going on your lawn, parcels.
I mean,
there's something.
There's a startup right there.
Is there something on your porch or these auto open boxes that defend against, delivery theft? All kinds of embedded monitoring of equipment, mines, agriculture is a big one. So monitoring and reporting of equipment or plants and soil and moisture and all these other things. So it's certainly going to be a growing area. Of course, robotics is kind of starting to happen. You see drones and rovers, and a lot of now, I'm one of the early investors in Ambi Robotics, but I'm also friends with Peter Abil in Covariant, and a number of other companies, plus one and onward. And I see these, they're starting to get real orders rather than kind of NRE test things. So partly because of the growing labor shortages. And so these microcontrollers, I think, will become, as they become more capable, especially little potentially sensing and controlling motion, that they'll be embedded in simple robotic tasks for doing, everything, all kinds of things, or processing.
Definitely. Welcome back, Satya.
Health is another big one,
Yeah, you're just in time. We're going to take another short break here. Kwabena, where can folks find you if they want to follow you on the wide old internet?
Yeah. So let me send out our link for our website. I'll just post that in the chat right now.
Yeah, please do. Say it out loud too. Some people are just watching.
So you can find us at OpenMV at openmv.io, and then we have a blog, a mailing list. So we're at about 10,000 strong now on our mailing list for been going this long. And we've got some videos on the website. The website hasn't been redone in a while. The last time I did this was like 6 years ago. So we're about to unveil a new website actually we're working on, and with new videos and stuff like that. I actually was running this company part-time for the longest. I had a day job. So previously I worked at a company called Embark Trucks, where I ran electrical engineering to help build fully autonomous semi-trucks. And yeah, moved on from there and kind of working on OpenMV full-time now, since it's been my passion project for the longest. And just trying to make it into something cool now. And I hope to continue to work with OpenCV and help support you guys in the future in any way I can.
Thank you so much.
Really appreciate it, Quab.
All right, thank you.
Fun fact for folks that don't know, Quab is my neighbor.
Yep. Bill lives across the street. I live in San Francisco.
I can literally see his apartment from my window. So
it's such a small city out here. If you're in AI and ML and you want to get into the game, come out. We need more people in the city. Got hollowed out during COVID. True. Things went ratchet.
Yeah. Hey,
seriously.
We've got an IKEA now.
Yeah. We got an IKEA, but we lost our Whole Foods.
Yeah.
And our Target.
That Whole Foods was only there for like 6 months.
It was there for a year, but yeah, I know it went out.
Was it the whole year? Wow.
Yeah, it lasted the whole year. But yeah, no, we need some more folks in San Francisco. Come back. Let's create the future.
Yeah. Absolutely. Thanks so much, Kwabena.
Thanks, Kwabena.
Thank you.
Yeah, we'll talk more about those OpenMV cameras on another webinar episode soon, I'm sure.
All right.
Right now, we're going to take another short break for a short film all about polymorphics. It'll last about 7 minutes, and then we'll be back for the home stretch of this big old live stream with Catherine Scott from Raw/Intrinsic, and also Adam Rodnitsky and possibly Brandon Miner from Tangram Vision. So stay tuned for that.
Thank you.
Share now. There it is. Oop, wrong button. Sorry, folks. Easy to fat finger stuff when you're doing too many things at once, you know? All right, there we go.
This film is about an idea we call the polymorphic concept of data processing system design, which is a complicated name for an idea, we admit. But the idea itself isn't so complicated when you think of it in terms of how people get machines to help solve their problems. Now, if you have a problem to be computed, you take it to a computer. And as your problems get bigger, you need a bigger computer. As more and more guys like you have problems to solve, they take turns on the computer, which isn't so bad if the computer is fast enough, which it can be if it is big enough and expensive enough. But as the number of guys and the number of problems increase, the machine gets huge. Isn't that a waste? Because while one guy is using the computer to solve an easy problem, which may only be taking 1/1000th of the computer, everyone else has to wait. Unless you spend still more money and buy a still bigger computer. But worse, if one piece fails, the whole computer will probably quit, even though most of it is perfectly good, ready, and willing to work. What's wrong here? To start with, if you look inside, you see that it isn't just one solid hunk of computer, but a lot of individual parts and circuits which each have specialized functions. Now it would be nice if someone would divide the huge computer into little parts, unsolder the connections, so that everybody could get a chance to use the parts he needs for his particular problem. Next, you will want to organize things a little. Not in the usual way, where the brainy computer part not only supervises everything, but also insists on doing a large share of the detailed work. What you want is more delegation, a more easygoing, cooperative relationship between all the parts, so that they can associate freely and directly with one another and in various ways. Isn't this a lot of fun? Actually, of course, the electronic boxes don't move. You just make a nice, flexible, automatic switchboard connection like the telephone company does. That way, the computer boxes, the real brains of the system, don't have to waste their time and talents acting like telephone operators, trying to handle every single message personally. They can stick to computing and let the other boxes do the detail work, such as remembering large number of facts or sending messages from one box to another or carrying out simple logical routines. And so, each computer box doesn't have to be so big now. This is distributed control, distributed memory, distributed arithmetics, distributed everything. And it makes sense because now more than one guy can be using the system at the same time to solve a number of easy problems. And when those occasional crash problems come along, your system can reconnect itself in a matter of microseconds to get the big urgent jobs done, as well as an ordinary giant computer could do them. And if one box quits, it's no great catastrophe. The system just automatically switches the job to another box. If you find yourself getting the busy signal too often, you buy more of exactly the kind of boxes you need. That's like adding on new subscribers as they move in. Or you can add more displays so that more people can see what goes on. Suppose your problem calls for a lot of detailed work to do most of the time. Then you buy boxes to give you all the memory or messenger service or whatever else you need. On the other hand, if your problems are mostly heavy-duty brain work, you can load your system up with computer boxes. When you really need it, and can prove you need it, you can put together a big system, or even a really, really big one, without over-investing early, or throwing anything away, or starting from scratch again. So you save money. And all the while, you have better reliability, and multiple use, and better access. You can even switch together two complexes, or three, or four, like a nationwide telephone system. Or you can connect in one of those ordinary giant computers as a subscriber if you go for super systems. And this doesn't mean that you end up with one big party line. You can keep some of the lines private by opening a few switches permanently, so that certain information won't be available to nosy subscribers. And so now you see that it wasn't just exactly a computer you wanted, but a group of guys with brains and a group of boxes with electronic brains and consoles and displays, all connected together in varying ways and growing together so that the partnership can solve more problems per dollar than each group could solve by itself. And this is all there is to the data processing concept known as polymorphic, many-shaped, or multiple mode, or the matrix concept, or maybe just the common sense switchboard idea in data processing systems. Now it just so happens that Thomson Ramo Wildridge has been working on the polymorphic idea for several years. And, in case you hadn't already guessed, we have built the first actual polymorphic system. If you're interested, let us know.
All right. I hope everybody enjoyed that short about polymorphics. It's one of my favorites from the 24/7 streaming channel that I run, Retro Strange, along with my best friend Noah, the station curator. He scours the Internet Archive for videos and films and short subjects that we can we're pretty damn sure we can use that are no longer under copyright for whatever reason. So we hope you enjoyed that one. We are here at the beautiful OnBase Productions facility in downtown Niles, Michigan, and behind the scenes all day has been my dear brother Charles, who runs the joint and owns the place. Chuck, this is not the only show that you tape here at OnBase Productions. What else happens here at OnBase?
Well, I'm not necessarily at liberty to disclose everything that happens here at OnBase Productions, but what I can say is once a month, we have something that we call the Nelson Family Radio Hour that we do here live with Noah, who is the curator at Retro Strange, and sometimes my partner Jess and our oldest son Hank, and then our youngest kid Everett joins them sometimes too. And it's like Rocky and Bullwinkle and Friends, right? We have people who pop in. We do interviews with people around the community.
I'm Boris Badenoff.
Right, exactly. I like to say there's music, stories, and swearing. So that's what we do on the radio hour. And then, so you can catch that on Facebook, Nelson Family Radio Hour. Sometimes we're joined. There's no swearing.
No swearing.
According to Danhausen.
Love that, Danhausen.
So YouTube and Facebook for the Nelson Family Radio Hour. And then if you want to go way back to 2020, what the thing that kind of started it all was What's the Big Deal was the name of the show that we created, kind of like a sketch comedy. We would start each episode with an interview, a live interview, and then we would go into some sketches that some comedy sketches that we had created collectively. And then
some of them were even funny.
Yeah, it's true. The Halloween episode I would highly recommend. That one was really good.
That's the best one.
But so with the radio hour, we have the live segments. Sometimes we have some shorts from Retro Strange.
Sure.
Like I said, we have interviews from community members. I've interviewed the owner of the pizza place down the road here. The next episode will have an interview with the owner of Goddess of the Moon Leatherworks. Who she has her own like blacksmith shop in her backyard. She's totally badass.
Story just keeps getting better.
Yeah, exactly. And she's the singer in a Motown cover band, the Motown Machine. Chandra is incredible.
Cooler by the second. Cooler by the second.
So maybe next time you do one of these, we'll have the Motown Machine on here.
Oh, hell yeah.
We can have that as the musical guest. So,
Hey, Chuck, when is the next episode of Nelson Family Radio Hour?
It was going to be today. It's usually the first of the month, but it won't be. So it'll be Friday. Whatever it's. I guess that's the 3rd, probably. If you believe in time. So Friday evening, join us at 7:15. For the next installment of the Nelson Family.
That's 7:15 Eastern
time, the only real time Eastern time.
So joining us up next on the show, one of our thanks for that, Chuck. Yeah. Joining us next on the show, one of our last guests is an old friend of mine, a friend of the show, fellow Michigander, Catherine Scott.
Hi, Catherine.
Welcome, Kat.
Hi, guys.
Why don't you go ahead and tell people who you are and what brings you here? Did you bring any rats?
Rats? They're over there. They were very busy last night. Since it was Halloween, they were out and about. They got peas. It was a good night. So what
Lucky
do I do?
rats.
I'm basically the developer advocate for ROS and Gazebo, which, if you're not familiar, ROS stands for Robot Operating System. Work really closely with the Open Source Robotics Foundation, which uses a ton of OpenCV. Prior to that, though, I've generally kind of bounced back and forth from doing computer vision work to doing robotics work. Used OpenCV for just about anything you can think of, everything from satellite image processing to medical imagery to building robots to doing basically mapping vehicles, manufacturing work, all sorts of different things.
Yes, and ROS is part of the open source Trinity Throw it up. I'm trying to get this hand signal over. We're going to do it, folks.
But no, and the reason I know
Diamond cutter.
the Ross crew is that, you know, I used to do a ton of work with OpenCV. I met some of the crew there, and this was when a lot of them were working out of Willow Garage. So long time ago, over 10 years ago. And sort of the rest is history. That was my first introduction to Silicon Valley.
Yeah, so the funny thing is that both Ross and OpenCV came out of this organization called Willow Garage. It was also a pretty strange organization, right, in terms of what they wanted to achieve. Gary may be able to put some more color to it, you know, the purpose of the organization, how it was organized, and how two very important libraries came out of that organization, Willow Garage. I don't know.
Yeah, I'd love to hear some history from Gary, if you're there, Gary.
In Willow Garage.
Your camera is off.
Sorry.
Oh, there's Gary.
Yeah, way back in the
guy cleans it up
times,
nice, huh?
There was this Willow Garage thing, and I think the roots go back to Stanford Redwood, where we were working on the Stanford AI robots, and Redwood was a system that you could pull together resources from a lot of computers, and that's how this robot ran for many demos and a couple of papers. And it was completely unwieldy because everybody had to be up and running for this. It was a flow graph. Everybody had to be up and running, distributed across the department for it to run at all. And it was Adrian Kaler and myself worked on that. And then we went away, and I think, God, I'm spacing on his name. The guy at Stanford, he started Ross as a distributed messaging system, and that came to Willow Garage. I was also there when Willow Garage was supporting these open source projects, which gave a large infusion into OpenCV, and sort of right when we were at most critical need for resources, we got this big boost in funding that allowed us to you know, scale up. Meanwhile, Ross became the operating system of the robot there, you know, that we were demoing things on, and that was the original the development environment for Ross, then OpenCV and things, and of course I then left to do industrial perception, which was later sold to Google, and Ross spun out of Willow Garage. Willow Garage ultimately folded or disappeared, but it left all these artifacts and companies that are around, and these projects that are still going.
That is often the case, I find, in tech, where the companies sort of rise and fall, but often the software remains. And this is actually one of the things
if it's open, which was a good thing,
yes.
you know. But,
yes.
Yeah, get really, after all these years, get really sick of good software getting thrown away because a company no longer exists.
Yeah, this is one of the things you talked about when I interviewed you for the OpenCV launch video here, that, you know, it's, and Gary mentioned this as well earlier in the broadcast, that one of the great things and one of the huge points of value to individuals, I feel, for OpenCV and large commonly used libraries like OpenCV, is it's stuff you can take with you. The company can fall apart, but you can still take that expertise and that knowledge with you with OpenCV.
That's right.
Well, it's also just a general accelerator because people aren't reinventing the wheel and have these open resources to start with, rather than, you know, having to hire half the team is just inventing the infrastructure to do what you really want. You can get to what you really want. And, you know, that's the main thing.
It's a shortcut in a lot of ways.
So, Kat, I mean, I have heard you, you know, complain on Twitter a lot about how so many people use ROS, and people usually think that, oh, they suggest features. Oh, why is this not in the library, right? And usually people think that, oh, people at these organizations are lacking ideas, right? And that's almost never the case, right? People have thought about all the limitations, everything, but it is funding, which is always severely lacking in most of these
it's not ideas, it's time and money.
Yeah, it's time and money almost always. It's always, yeah, we've thought about that. Oh, there's a ticket outstanding for that. We'd love to do that. It's just that, we have 1 or 2 people working full time on things. We don't have, and there's community contribution. I don't want to, say that there isn't community contribution, but if you want to make steady, regular progress that isn't the progress of, oh, I had a weekend and I clobbered this thing together, the progress that you can really use for professional sort of endeavors, you need to pay for. I mean, it has to get paid for some way. And the thing that I find most troubling is that there's just the number, we keep internally for the Open Source Robotics Foundation a list of companies that we're fairly confident use ROS, and it's in the, it's easily, right now the list is like 800 and something. It's probably realistically closer to 2 or 3 times that. And we're talking everything from like Fortune 50 companies to 2-person startups, and just never, there are exceptions to this. There are, companies out there like members of the ROS 2 TSC and members of the like ROS Industrial Consortium that do contribute. But by and large, the vast majority, probably 95% of the organizations that are nominally making money or trying to make money off of software, off of open source software, do not contribute back to it in any meaningful way.
Right. And the fun thing is, not the fun thing, the sad thing is actually that there is a very easy path to monetization for most of these libraries, right? I've mentioned several times to Gary that this is a hypothetical situation. This is not a real situation I'm talking about, but hypothetically, if OpenCV 5 did have a commercial license, right? If you said that companies above a certain level, right, they have to pay for the library, then our funding needs are solved immediately, right? Instantly, right? Because all we are looking for is $1 million in funding for the developers, right? And this would be half of it. I want to fund it through this crowdsourced campaign, and half of it would be through the industry. But let's say we just said that, okay, if you're a company which is making more than $50 million a year, right, then OpenCV is not free for you. It solves the problem immediately, right? It solves the problem immediately. They'll get better support. We'll have to have, we can have a staff which we can keep around, right? It is not an ad hoc group of developers who contribute when they can, but they have a day job to work on and things like that, right? But we have not done that, right? The reason we have not done that is we want to keep OpenCV free for everybody. OpenCV 5 for free for everybody, and that's that's a decision that was made in a board meeting, and they were we met in Turkey and we decided, okay, this is how we are going to proceed. We are going to keep OpenCV 5 free even for commercial use, just like all other versions of OpenCV. But the solution is very easy. What we are doing is the harder way, right? We are going the harder way, asking for donations from the community, etc. And I'm hoping that people pull through and donate to all these organizations, OpenCV, ROS, etc. All the things that all the tools that make life easy for developers. We want to get contributions from developers. Another reason we are going down to the developers and not asking, I mean, we are still asking large companies to donate as well, but the reason we want developer contribution is that we don't want the agenda to be set by large companies. We want OpenCV to implement the features which are right for the entire community, right? And we have to serve the
very important point.
Yeah, right. And so that's why, I mean, this campaign, we are hopeful that the community will pull through.
And we have 45 days for this campaign. We are at 13,000 right now. I've actually never done a campaign that has done so badly in my entire life, right? Just to give you a perspective.
It's funny, but it's not funny. But yeah,
Yeah,
I mean,
the very
normally
first campaign
we're
we
selling
did-
something, you know?
Right. So when we were selling something, right, the very first campaign we did for OpenCV AI courses, we raised $500,000 with the help of 1,300 backers. And in the first 20 minutes, we had $50,000, right? For OpenCV AI Kit, when we did the Kickstarter campaign, I think we had $100,000 in the first 10 minutes, right?
Yeah, it was about 10 minutes.
Right. So if you make OpenCV a commercial thing, right? Oh, you have to pay for it.
We would have been done
You're
by
getting
now.
a discount. It solves
Yeah.
me. We could have raised a couple of $1 million from this campaign if OpenCV 5 was a commercial, thing. But it's
funny, but not
ironic.
funny.
Yeah.
Yeah, but there's also a lot of risk involved with those sorts of things as well. If they weren't successful, you're on the hook for quite a bit of money for production and also like NRE and all of the things that go along with that, whereas just direct sustainable funding is probably the most important thing you can do to sustain these organizations. I'm in the weird position, right, where I talk to you guys and Drone Code and OSHWA, or the Open Source Hardware Association, and the Open Source Robotics situation. I think we're all, in that same boat where we try to serve a community, but they're, making sure that there's a sustainable funding source for these things is extremely difficult. And occupies,
Yeah, seems to be
unfortunately,
getting
more
harder.
of our time than we'd like.
Right.
Yeah, I want to get back to making videos and stuff. I'm tired of raising money, guys. Have mercy. Have mercy.
And
Kat,
it's
can you?
Well, I was going to say it's interesting because it's like I look at, I stopped paying for YouTube Premium or whatever because the price went from $5 to $10 to $15, and I look at, just how bad some of the things that used to be free are, and the fact that this software continues to be free, and it's, I think all of these orgs would be a lot better if we get to the point where Wikipedia is, you start a funding campaign,
And the YouTube
the ads go away within 24 hours as soon as the goal is met, which I think is the way to go.
The YouTube app, in fact, on iPhone at least, and I'm probably on Android as well, one of the many software projects that uses OpenCV. If you go to the YouTube app and then go to About, and then I think it's Settings, something like that. They're open source licenses right there, OpenCV.
Yeah, Instagram too.
Same with Instagram. Yep.
Yeah, the number, it just, it's strange when you have the best, even simple things, right? Like resizing an image or like changing formats, even though there are a couple other, free and open source libraries that do this, it's just immediately like OpenCV is suddenly the go-to for all of these things, just even for simple functions. But I'd imagine some of them do more complex things, but that's, the number of servers out there that just do, like, you uploaded an image, make that image a thumbnail to put as your profile photo is just, it's got to be half the websites out there.
Right.
That would not, you're absolutely right. We talk about this occasionally on the show and amongst each other with everybody on the call here right now, but there's estimates out there that OpenCV is used in like 80% of embedded vision applications and 80% of vision applications in general, which
I was
is
talking about this with respect to OSHWA to a few people the other day, and it's something like on the order of 70-80% of companies are built on open source, just pure, like of all software companies, 80% of them are using some form of open source. And
you had a tremendous quote that I did not get to use in the video, and I'll let you give it live here though.
This is my favorite one, that there are two kinds of companies, those that use open source and liars.
Those are the two types.
Those are the two types.
It's a
binary. Even if it's not in the source code, it very likely is the compiler, right?
Yeah,
at least.
I mean, gone, fortunately gone, is the time and place where you'd have to pay for your compiler, which is, I think, people, we sound like an old timer here, but like you used to have to, you used to buy a compiler. You could buy certain compilers on disk,
The kids
on
these
a bunch
days
of
don't know how
disks,
good they got it.
and you needed that to compile the software that would run on your computer, and you needed to pay money to build software for your computer, and that's gone. That's not something we realistically do that often anymore, except for some embedded platforms.
Yeah, that's absolutely true. So we talked a little bit about PX4 Developer Summit, and amazing in New Orleans last week. And right before PX4 Developer Summit was ROSCON. I flew in on the last day of ROSCON and got to see some buddies there, one of whom was Steve Simpson. Hi, Steve. Kat, tell us a little bit about ROSCON this year.
Oh man, ROSCON was, oh man, New Orleans is a rough place to have ROSCON. Yeah, so every year
You're still recovering.
I really, realistically am still recovering. So ROSCON is the yearly ROS, so Robot Operating System Developers Conference. I think this is year 11 or 12 that we've had ROSCON, and it's essentially, or more or less, grown every year that we've done it. This year was about 800 developers from 42, 43 countries. 3 days, so a day of workshop, and then 2 days of talks, lightning talks, birds of a feather sessions. We also have a ton of exhibitors. And what's interesting to me is I don't want to say the number of companies now that kind of stake their business on ROS. It really is becoming a thing that, like, you have to support ROS to be able to build components for robots, and it's a very quickly growing market, and just the number of people who are really interested in supporting this open source ecosystem for building robots. And it's, I think to a certain extent along those lines, it's, having a neutral arbitrator between all the vendors is sort of existential to making this happen, right? Is that we're just not going to, if everyone is a bunch of proprietary code and APIs to actually build robots, nothing's ever going to get done. So it's been interesting, especially to see the growth just since I've started 5 years ago. It's really been, the classic hockey stick thing that people tell you're going to see in your startup. Well, we're seeing it in open source right now. And computer vision is not that much different. When I started, computer vision was not a field that was going to yield, a robust career. And now it's like all of the graduate students that graduate are like, oh my God, computer vision, I want to do all the interesting stuff.
That's true. And one of the companies who's building heavily on ROS will be our next and possibly final guests on the stream coming up shortly. The folks from Tangram.
Oh, they're going to come over and hang out tomorrow.
Nice. I will. I mean, you can hang out while when they join here shortly if you like. Right now, though, I'm gonna play one more video here. We talked a little bit about some of the great pioneers of computer vision and AI. One of whom is Gary, who we've got here. A few years ago was OpenCV's 20th anniversary, and as part of that, this was before I joined the organization, but as part of that, OpenCV got to create this great series of short videos with interviews with some of the luminaries who really believe in open source and have had awesome careers. One of whom was Andrew Ng, and so we're going to play a video from the OpenCV 20th anniversary a couple of years ago, featuring Andrew Ng. As soon as I can find it. Okay. Don't mind me, folks. Just got to get the old wet dry vac. Footage. Can you tell it's been a long day? There it is. Okay. Sharing.
I had the pleasure of working closely with Gary Bradsky, as well as Adrian Kayla at Stanford University. One thing I remain grateful to Intel for this day was many years ago when I was building up the STAIR or Stanford AI Robot project. Gary Bradsky and Intel found the funds to donate a robot arm to me at Stanford. And so we use computer vision to do things like, can you get a robot to pick up an object that has never seen before? It turns out today, yeah, of course, you do that with deep learning. This is, well, you just do it. What's so hard about it? But when we're doing this work for the first time, it was actually a very controversial topic because a lot of computer vision and robotics researchers thought that if you want a robot to pick up, say, a pen that's never seen before, well, surely you've got to have a 3D model of a pen. You need a 3D CAD model, so a robot can compute how to put its fingers around the pen so as to pick it up. And so my group, we thought, no, we don't need a 3D CAD model of something just to pick it up. We said, we're going to use machine learning to learn to do it. We're going to take a picture of whatever object you put in front of the robot, and then just based on the picture, we'll use machine learning to figure out how to position the robot's grippers around the object so you can pick it up. OpenCV was a key part of the software we're using, and it was actually really cool when, we could get a robot to pick things up without a CAD model. But I think that work changed a lot of people's thinking about what is possible with machine learning. Over the last 20 years, the rise of computer vision has been incredible. Starting with many applications, even before the rise of deep learning, there were more and more computer vision projects being done. For example, with the DARPA Grand Challenge and DARPA Urban Challenge, using computer vision as a component of self-driving cars. And OpenCV was right there running in those cars that, Stanford and many other places built that heralded in the modern era of self-driving work. And open source tools, OpenCV, deep learning frameworks have played a huge role in enabling all of this exciting progress. Because of the rise of deep learning, there's now the potential to deploy far more computer vision applications than ever before. It just works so much better than it did, 10, 15 years ago. And so the number of application use cases has opened up dramatically. And I think this enhances the importance of OpenCV because more than ever, there are more developers than ever that need that software layer to build on top of in order to actually get this stuff to work out there in the real world. But I think this explosion of computer vision developers will cause there to be more and more use cases on which people will be counting on OpenCV for in the future as well. In the software world, we all stand on the shoulders of giants, and it's by sharing our work and building on each other's work that together as a community we can build these amazing software products. I think OpenCV has been one very important building block built by giants that I think all of us should feel privileged to be able to stand on their shoulders. Gary Bradsky and the whole team that he led deserves a ton of credit for leading the whole OpenCV effort. So congratulations to everyone that's contributed to OpenCV over the many years, and happy 20th anniversary.
That's a great video.
Yeah, Gary, any memories of any of those early days? Did you ever work with Dr. Eng?
Yeah, I'm on a paper or two with him, and we've remained friends over the years. He obviously has ascended into the godhood of AI and whatever. He was he recognizes trends very early. So some people, I was starting to get interested in deep learning. He just jumped right on it. Just dove in. And I went to Stanford for the sabbatical, and that was. I did a number of things, like I said, this precursor to Ross there, and a bunch of papers. I did a paper with Andrew Ng on, we looked for kernels that could be accelerated in machine learning, but these were pre-deep kernels. So there were classes of things that were, basically tensors or matrix operators. And I went on and did 2 papers out of that. One was an oral at NIPS. Now it's Neural IPS. The other was at a hardware conference done with Kunli Olukotten, who was a hardware guy there. And that got best paper for these accelerated kernels, and some of that was a progenitor of this current work where he's now also running a chip company, a generalized AI accelerator, a chip company that sells to enterprise, but it's doing quite well. But during that time, that's when the thoughts of the DARPA Grand Challenge started coming up. There was luminaries there at the time were, of course, Andrew Ng, then Sebastian Thrun, Daphne Kohler, and we were the ones who came together with some other professors and started this Stanford AI robotics project. Actually, he talked about that robot arm. I went to him and said, look, Stanford was early on robotics, like shaky and whatever. And I go, don't you think we should be doing this again? And I had bought this arm because I had a DARPA contract. It was only paying for students, that it was supposed to hire students to work on this. And I saw that, the administrator of that was retiring. DARPA rotates these people through. And so usually the projects get canceled. So I go, it was on cognitive architectures, and I go, this thing's going to get canceled. There's no point like getting a student to write a little piece of one of these DARPA show fests that I felt was useless. And I go, but a robot arm is really useful. So I bought one. And then, of course, until I sat in a room with a room full of lawyers because I had violated the terms of the DARPA contract. And I was the one who read it and says, well, it says if the administrator says it's okay, then it's okay. So I just, during the meeting, I'm just writing him, look, I thought it's better. We need some hardware to leverage this stuff. I bought an arm. Is that okay? And he goes, okay. And so I go, I think I solved the problem. And so I had this robot arm, and then I go, well, one of the stipulations was that it be transferred off to another, DARPA contract. And I go, well, there's tons of those, related ones at Stanford. And so Andrew Ng had these, and I go, we should get this arm going. And that's how that arm is still there. You can go in Gates, it's still sitting there. But it became like I guess like the seed around a whole bunch of projects that started that ended with the PR1, then PR2 robot, which got Scott Hassan involved in funding Willow Garage, which also out of which ROS came as a reaction to Redwood, which we were using internally there. And so a whole ton of things came out of that arm. So, probably the most valuable robot arm in history.
To be in the Computer History Museum along with the PR2. Speaking of which, dovetailing, all of the PR2 design files are now open hardware. But I was going to say, I was going off the other day on maybe related to government funding, research funding, but if you look at open source in particular, like what is it, the H index or something? I want to know what the H index is of open source projects, because I was looking. The original ROS paper has something close to 12,000 citations. OpenCV is in that ballpark.
Actually, they don't cite OpenCV anymore. It's become like water, right? Let's say you use water in a recipe, right? You don't say that, oh, I poured so much water. I mean, you don't, in the ingredients, you don't say water, right? So OpenCV is something like that. Everybody uses it, but it is so ubiquitous that people don't feel that they need to cite in papers, right? So that's the recipe analogy.
But go on with that point, because I think the government ought to fund open source more.
Yeah.
Yeah, they're starting to. That's what I was complaining about, is that, whether that's actually going towards where it needs to go, it was kind of questionable. A friend sent me Travis Oliphant. I don't know if you guys don't know who Travis is. He's one of the people behind NumPy, and he claims at this point that something on the order of 25% of all scientific publications are now using NumPy for data analysis. So that's which I would believe him. Like which as an alternative to MATLAB, there's pretty high penetration in academia now. And I really wouldn't be surprised if for most scientific domains, if a quarter, if not half of the analysis is done with open source hardware. Open source software. Hardware, maybe soon. But that's it's that's how important these things are, and they don't get nearly enough funding.
I know, and it used to be Huawei would step up and fund this, and I go, well, what happened to that? But and I've even had I was talking with an Air Force guy, and I go, yeah, I know that there's not enough funding for the stuff which we use, but I had this other funny example. There's some library, and I can't remember the name, but it's a it's a processing pipeline that's used for like really fast data, and it's an old project. It's older than OpenCV, and apparently among its uses are in the national labs and like the linear accelerator and cyclotrons so we had in Google Summer of Code, we had this thing on legacy systems, and I can't remember the name of this project, but in either case, they said, well, the labs use this for data collection, like when there's collisions and stuff. It's a very fast parallel machine made out of 6800s, the processing chip. And the guy who maintains the backwards compatibility of that code to the 6800 for the purposes of this data collection was sitting next to me, and he's literally a 70-year-old guy, totally white hair, and I go, you remind me of that XKCD comment, that the internet has all. It's like children's blocks, and it's all held up by this little toothpick, and that's some guy in Wisconsin, right? And I go, you're the guy.
that guy's infrastructure now.
But it is a little absurd that not only that these systems end up being legacy systems, because there's probably some funding at that time that they built up the supercomputer data collector, and it's never been done, redone since. It's not a commercial product. And so this guy is maintaining the backwards compatibility, but he's like, well past Social Security.
Yeah.
Anyhow.
Speaking of well past Social Security, joining us on the channel now is Adam Rodnitsky from Tangram Vision. Adam, welcome.
Adam.
You're still muted, pal. Proving me right.
Now I'm not. Yeah.
Welcome, Adam.
Thank you. Good to see everybody. It's a great group of people on right now.
And Tangram is just to give an introduction, Tangram is the latest addition to our bronze membership. Adam literally wrote us a check. I mean, not like he transferred money. He literally wrote us a check during the Drone Code Summit we had. And thank you so much for being the bronze member. Really appreciate your support.
I heard that happened at like 3 in the morning.
It was a late night money Passover. It was done appropriately for just outside the French Quarter in New Orleans. So
yeah, we went to Parasols, and did you have a catfish po' boy?
I had the roast beef smothered po' boy.
Roast beef one?
It was incredible.
Yeah. I went back and had that. It was extremely good. Shout out to Parasols, like the platonic ideal of a neighborhood bar, I would say. Just excellent spot. Adam, tell us a little bit. Tell us who you are, and tell us a little bit about Tangram.
Sure, I'm Adam Rodnitsky. I'm one of the co-founders of Tangram Vision. We are a group of perception engineers who sprung out of like many of us here. We've had some relationship in the past with occipital Many of us at Tangram Vision came from Occipital, where we built depth sensors and great computer vision software. And at Tangram Vision, we sort of coalesced around the idea that a lot of robotics companies struggled with complicated infrastructure like sensor fusion and calibration. So we've built some, fairly sophisticated set of tools for those purposes. Like many other people in this world, OpenCV has been a key part of that. Even before my experience at Occipital, OpenCV has been a part of my career. So, not to date myself too much, but I think the first time I used OpenCV was 2007. And so, I've sort of been in and around this for quite some time.
That's great.
And from I've said this before, but Tangram basically hired everybody I would have hired from Occipital. So
yeah.
Tangram, the calibration demo I saw, the self-calibration demo that I saw, I can't remember where I saw it. I think it was in the Embedded Vision Summit, or
might have been CVPR, I think.
Oh, CVPR, that's right. Yeah. That was mind-boggling how good of a self-calibration it was.
Yeah, it's been sort of an exciting thing for us to work on for the past few months, and in 2024 we're going to be really accelerating that. Right now, we can auto calibrate cameras, depth sensors, IMUs, and then we're going to be layering in radar and lidar as well. So it's we have a slightly cynical view on auto calibration. In many cases it's kind of overkill. And if you're in a sort of a compute constrained environment, do you really want this running all the time in the background? Probably not. But this is for many companies though something that they're looking for. So we're building it. Yeah,
that's great. It's great.
Excellent. We got to see each other at the you were part of ROSCON. Tangram Vision was part of ROSCON. We saw a robot spill a can of soda, if I recall correctly.
That's right. It was a Unitree dog doing a flip with a can of soda on its back, which might have thrown the balance off a little bit, and it's subsequently crushed the can of cola. And that was the robot survived. The soda did not.
I've said it before on this show. My favorite thing is when people involve robots and liquids, and I got to see both of them at once. It was great.
Yeah.
She should get into maritime robotics.
Yeah.
Before I forget, Kat, can you tell the folks where they can follow you on the various internet places that are out there?
Oh, well, I'm everywhere. It's just KSCOTC on everything. The more important thing is the Open Source Robotics Foundation. So just openrobotics.org on just about every platform. We stay off Facebook and Facebook related things, but we're around. We have a ton of forums. That's actually where I would point people first if they want to build a robot. Okay. But I also move the news around. So if you're interested just in robotics news in general, we seem to be the center of mass for a lot of it. So
heck yeah.
I have to say every week I go to the discourse post of the weekly robotics news that Kat posts. Super helpful.
Yeah, I think I'm going to start making that go a little bit broader here, which would be cool. When I get a minute in my infinite spare time.
Speaking of going a little bit broader, and speaking of a guy with infinite spare time, welcome to the show, Joseph Nelson.
Hi, Joseph.
Hey, everybody. What a great group to join. It was awesome.
It's awesome.
Yeah, and I thought,
again, I have to introduce people from their membership, right? RoboFlow is a silver member for 2 years, and they have supported us for all this time. But not only that, Joseph has been on our weekly webinars a few times, I think 4 or 5 times, and he's the
current record holder for most appearances.
Right, and whenever he's there, we get a lot of excitement, right? A lot of people want to come and see the way he teaches stuff on the webinar, because it's usually a kind of we pick a interesting topic to talk about, and then he does usually sometimes kind of a tutorial, or sometimes very interesting way of presenting the ideas. So RoboFlow, it has been a great partner, not only in as OpenCV Silver member, but they have also helped us with OpenCV AI competitions by giving free credits to our users. A great partner. Welcome,
Which we
Joseph.
very much appreciate. Joseph, why don't you tell the people that don't know who you are?
I'm one of the co-founders at RoboFlow. We're big fans of all things open source computer vision. We build tools for kind of the three core primitives: data sets, models, and deployments. About 250,000 developers build with our tools so far. That's individual developers and over half the Fortune 100 now. Maybe one of the most recent kind of fun use cases with OpenCV and RoboFlow that comes to mind. Recently, we made sort of a game called Paint.wtf. Actually, we made this game 2 years ago, but I remade the game with OpenCV actually a month ago. So Paint.wtf basically says, if we use an LLM to generate some prompts to play AI Pictionary, and then we have an AI judge your drawing who did the best job. And so we use GPT-3 to create a bunch of prompts like a giraffe in the Arctic, or like an upside down dinosaur, or a bumblebee that loves capitalism. And then the user is given like a canvas in the browser and they draw. And then we use Clip, a large model, to compare how similar the image is to the text and whatever one is most similar. So we made that actually almost 3 years ago, but I just rebuilt it with OpenCV. And by that, I mean, previously users would draw, in the browser with Microsoft Paint. In fact, what I did instead is using OpenCV, I have the user use their webcam module. And so you can draw something in the real world and then hold it up to your webcam. And then you get to determine if you were the closest person to draw related to the prompt. So maybe this is my fun OpenCV build on top of it of the day story.
That's a fun one. Yeah. We also built the rock, paper, scissors game for Embedded Vision Summit this past year. That was really fun. A few people defeated the AI. I think once the AI can beat us at rock, paper, scissors consistently, it's all over for humanity. That's the last line of defense as far as I'm concerned.
But I did that at Intel way back, simply because humans aren't random; they correlate, and so
that's a grad student problem.
Humans, unless you're using some kind of counting strategy or something.
We totally had to do this for one of my graduate classes like 10 years ago.
That's funny. What do you remember any interesting results from that, Kat?
I don't want to say how long ago this was.
You don't have to.
No, I seem to recall that the strategy was truly random. What?
So
there was a thing in the New York Times about it. Let me see if I can find the New York Times thing.
Oh, I've got Joseph. Well, she's looking that up. Tell us a little bit about what RoboFlow's been doing recently, aside from just nifty fun projects.
We put a lot of emphasis on kind of two things as of late. One is we open sourced our inference server for serving models. So we've over the last couple of years served hundreds of millions of calls across tens of thousands of models for users, and in that developed an intuition for common sorts of problems people bump up into. And we ended up building our own inference server, kind of purpose built for serving computer vision models. About 3 months ago, we open sourced that, and so we've been doing all we can to ensure folks are able to find and build and use that for basically deploying to maybe your own cloud or to an edge device like a Jetson or things like that. So that's been a big focus, and making it so folks can use both large models like Segment Anything and Clip, and small models like YOLO models or Detectron alike. So that's been a big focus. And another big focus has been around increasingly improving and understanding data sets. There's tons and tons of tooling that is useful for doing both semantic search or tag-based search or just general understanding images. And a big part of that work has been in the realm of multimodality. So with like GPT-4 Vision coming out, can we use these large foundation models to tell us about our images and maybe create zero-shot capabilities and kind of short circuit how much data we needed to actually prepare. So we've been doing a lot of experimentation, and an open source project that we've worked on in this domain is called AutoDistill, which basically allows you to use what a large model may know about your data to auto-label it or auto-create a purpose-built task-specific model, with the thesis here being like big models know a lot about a lot, but a lot of problems you need to know a lot about a little. So can you take what a big model knows and then turn it into a model that's yours, that you own on your data, that you can then take and use? So these are a couple of projects that we've been tinkering with quite a bit.
Awesome. Yeah, such cool stuff coming out of RoboFlow. A really good group of people. Seems like the vibes are very much on with RoboFlow. Before I forget, Adam, where can people find you on this wide open internet?
Yeah, well, probably the best place. You don't want to follow me personally unless you like old British cars. Like, that's boring. But if you want to follow stuff that's relevant to the world of computer vision, go to find us on. Oh yeah, there we go. Nice. This is actually our test vehicle with lidars and cameras on it. Email me for a sticker. I'll send you one. Adam@tangramvision.com. But yeah, go to tangramvision.com or @tangramvision on your favorite social platforms and find us there.
The new
Sweet.
camera, the information is public, right? I mean, do you want to briefly talk about it?
Yes, there's something else. This.
Ooh,
So
look at that.
we are launching a 3D sensor at Tangram Vision, which has all of our software running on it. So it's self-calibrating. It performs sensor fusion direct through a GPIO port on the back, has Ethernet and USB. Actually, relevant to what Joseph does at RoboFlow, it's got 8 GB of onboard memory and a neural processing unit that runs at 8 TOPS. So you can actually run neural nets right on the edge with quite a lot of power and quite a lot of memory. So we're pretty excited. We will be doing our own launch in a couple weeks' time. So follow us on Tangram Vision for more news on when that happens.
That's awesome.
That's great. That's great. And we'll also add, one of the tiers levels.
Yes.
We'll also add Tangram Vision camera so that, half of the revenue goes to Tangram. It's basically you're giving us those cameras at cost for our developers, and the other
slight
half
discount
goes to OpenCV. Yeah.
They're giving us a deal.
We are.
Yeah. All right. Thank you so much.
Joseph, where can people find you on Al Gore's internet?
Probably at RoboFlow. It's probably the best place. Me personally, my handle is Joseph of Iowa. So JOSEPHOFIOWA.
Yeah, we've got
Go Hawks.
Midwestern supremacy going on right here on the panel in this moment.
I most recently shared my handle is Joseph of Iowa, and someone responded, they go, Iowa, you mean idiots out wandering around? And I said, that's the one. That's the one.
Savage.
Well, thankfully they didn't say the one where they grow the potatoes or
Well, we don't,
I mean,
we don't have
close, it's
anyone
close.
from Ohio though, right? That's the real problem.
Thank God. No, we don't allow them in here.
No, no one from Ohio is allowed.
No Ohioans. Hi, Jessica.
actually this is
I'm gonna invite. What's that?
This is my Keith here, Iowa City poster.
Love it.
So, yeah.
I just walked. I often walk by the installation over by Moscone in San Francisco. Keith, very important.
My Halloween costume was corn on the phone. So here's nice.
Oh, Joseph. What are we gonna do with you? I'm gonna invite a longtime viewer, Steve Simpson, to. Steve has been on. Watched pretty much every episode of the show. He's got a new startup. I told him he could hop in and talk about it for a second before we called it a day. Let's see if he's still around here to get it.
So after
Whether
Steve,
he is or is not, I know what I'm doing tonight. I'm going to have a Thanksgiving dinner pizza from Pizza Transit in downtown Niles, Michigan. What's that, Satya?
Well, I have, there is a question from
Joseph, he wanted to know some of the details of funding and how OpenCV is funded, who are the, how the team is organized. So I just wanted to spend about 5 minutes doing that.
Yeah, that would be great.
I personally have to
here's
jump off for the
Steve.
top of the hour. Thanks, everybody.
Yeah.
All right. Thank you so much, Joseph.
Yeah, absolutely.
All right, adios.
Yeah, I'm
Thanks,
here.
Joseph. Hey, Steve.
Hey, I'll just join. I don't know if you want to see my Indiana Jones costume from last night, so I'll just join audio. My name is Steve Simpson. 40 years as a robotics engineer. Now into got bored of that, so now I'm into machine vision, machine learning, AR, VR. Probably been going to VRTO, which I highly recommend, for about 5 years, and got an amazing killer app idea about a week ago, actually. And essentially, I've got my first employee. We're actually looking for people to join us. My first employee, we're basically for people that have the right skill set, 5% net profits and 5% ownership in the company, which I think is going to be very lucrative. So I guess, Phil, yeah, I think you have my contact info. You can pop it up there.
Yeah.
And I can't say too much about it without an NDA, but what I will say is it leverages some interesting hardware in the iPhone Pro, and it does relate to Matter. And we will be first going out on the Apple platform, so it's incremental. Phase 2 will see us moving to AR on the Meta Quest 3. And phase 3 will see us moving to the Apple headset.
Mysterious
also incremental
and intriguing,
because,
Steve.
Sorry? Was that?
And mysterious and intriguing.
Yes. So please contact me if we can. I
yeah,
can
go
have
ahead.
room for up to 45% because I want to keep 55. I want to controlling whatever. So we're looking for. We have 1, and we're looking for 8 more qualified individuals. Please reach out. Send your CVs.
Go ahead and say your
let's rock.
say your contact info out loud here for folks that are watching.
Okay. So personal email, Steve, STEVE, F as in Foxtrot, SIMPSON @gmail.com. The official, we just registered the whatever folks 2 days ago, and that is Steve at ssindustриalautomationca.com.
All right.
And
so
we're going to change SS Industrial Automation. We still have to come up with a name, sexy name related to our product.
Okay, gotcha.
All right.
No, you got to start with the board.
I really
name,
appreciate that.
Come
see us
thank
at,
you, Steve. Thanks so much for watching.
Yep. All right, cool. Thank you.
Adios.
All right. Thanks, Steve.
Satya,
Yeah.
as you were saying.
Okay, what I was saying is, okay, first of all, let me finish this list of features first, right? And then I'll quickly go on to, can you see my screen?
Yeah.
Okay.
Sure can.
So yeah, in OpenCV 5, one other thing that is coming is better support for depth cameras. Right now, we have support for orbit cameras, but we want to expand it to other depth cameras so that you plug in the depth camera and it natively is able to work with depth cameras, right? No other code required. We also want to develop algorithms for point cloud processing, as well as 3D visualization support. Right now, all the high GUI stuff you see on OpenCV is 2D, and we want to have OpenGL-based 3D visualization support. Again, high GUI, we want to expand it, the TrueType font support for it with full Unicode, as well as better 2D and 3D visualization. And this visualization basically will be powered by, through OpenGL-based visualization. So right now, most of the things that you do with high GUI all of the things you do with high GUI, they are 2D based, and we want to take it to 3D visualization. Packages, we want to have OpenCV supported packages for Android, better support for DIY platforms like Raspberry Pi, Jetson, etc. There is support right now, but it is not as good. For example, Raspberry Pi Foundation, they have their own OpenCV releases, and we just want to work with them, make sure that we are helping them out in these releases, etc. So we will have better support for these packages, and of course, wider support for OpenCV Python. So OpenCV Python usually lags behind the C++ version of OpenCV, and with this, we will have better support for OpenCV Python. There is a lot of code refactoring that will come along. First of all, OpenCV 1.x C style API will be completely removed because it's not removed. It will be in the contrib library, but the core OpenCV library, we want to make it smaller. So we are going to remove the C style API. We are also going to remove a lot of obsolete algorithms or algorithms that do not represent the state of the art anymore, and they are rarely used. And this includes hog cascades, hog people detector. There is a new version of Ransack now, and so the old version will go out. We have a whole bunch of tracking algorithms implemented in OpenCV, and we don't need all of them. So we'll test and figure out which are the ones that are most relevant and move the others to OpenCV contrib. So all the code
turns out the state of the art changes over time.
Yes. Yes. So we have to do this refactoring. That is quite a lot of effort, but we have to do it. Otherwise, the library keeps growing on and on, right? And of course, the tutorial and documentation, we are going to improve substantially. We are also planning to fine-tune LLMs so that the documentation is in the form of a chat. You can talk to the LLM and get good quality code as well as documentation. Even now, ChatGPT does a very reasonable job, as Vikas had shown, of producing OpenCV code. But we believe that if we fine-tune these things on our end, it will be much better in quality. Okay, so there was this question that how yes, there was this question is about how is OpenCV 5 funded, right? Let me go back. Sorry, this was not from the start of the. Okay. Yeah. So basically, we want to fund OpenCV 5 through two means, right? We need about $1 million for developers. 50% of that can come from corporations and 50% from individuals. And the reason this split is very important is that we don't want corporations to dominate, right? Whenever they donate money, even though they have been very nice to us, usually, there is. It can come with some strings attached that, okay, some of the work would be done for their platforms, etc., which is perfectly valid. It still improves the library, but I think we need to have some budget, or at least 50% of the budget should come from non-corporations, individuals, so that we can work on features that the community cares about the most, right? And then, we had three options. We chose the first option, but we had discussed these two other options. One was the moral license, which we say that, okay, you don't have to pay, but if you are a big corporation, then you are obligated to pay, morally obligated to pay, right? And we also we are also thinking about a commercial license, which if the fundraising goes well, then okay, we don't need this. But if the fundraising doesn't go well, then we can have, for small developers, small companies, it could be free. And for larger companies, we can have a commercial license. And finally, the first option we are exploring right now, which is ask the community. Okay. How is OpenCV funded? These memberships and partnerships, we have corporate funding. The top gold membership is about 100K in cash or developer time or other resources that companies provide. And in this category, we have Intel, we have Microsoft, we have Google. Google supports us through Google Summer of Code. And then we have FutureWay as well as Huawei. These are companies that have paid us 100K in cash.
And also unofficially, you personally.
That's right. So, and then we have the silver membership where RoboFlow, as Joseph was here. We have Hackster.io, which supports our program for AI competition. We started
the official community platform of OpenCV. Shout out to Jessica and Alex and Ginger.
That's great. And then we have RunPod, which gave us free compute hours on their platform for our course members. And this donation is of the order of $30K per year. These slides were made a little bit. Tangram is missing here.
He forgot to cash the check, Adam.
Yeah. I'm so sorry. I'm so sorry, Adam.
We know we're there.
Tangram is also a bronze member. It is the latest. In fact, this slides I had made right before the conference, and my apologies.
It was before I had chance to work my magic on Adam.
Right. So so there are three companies. Intuitivo, this is a company out of Latin America, and just remarkable story. The guy Jose Benitez, he basically was a student of OpenCV University, and he basically created a company that turned display refrigerators into vending machines and using computer vision. And he was so successful, he raised $7.8 million. His company raised $7.8 million for developing this idea. And they have installations in several places in Latin America, as well as in Miami.
It's a very inspiring story too, because Jose, as a guy who grew up on government cheese and food stamps, like it's so awesome to read Jose's story, which we talked about in the OpenCV blog, that he was just dead broke, but really wanted, had good ideas and had the desire and will to make them happen, and raised $8 million damn near, like super impressive.
But not only that, Jose was also selected among the top 35 innovators under the age of 35 by MIT.
Latin America,
in Latin America by MIT Technology Review. And he came to us. Actually, we did not have this bronze membership program. He came to us and said that he wants to donate money to OpenCV through his company, because just a way to give back. And we created this bronze membership, $6,000 per year. And Intuitivo was the first company that joined us, followed by Drone Code Foundation. And now we also have Tangram as part of the bronze membership. We also have development partnerships with companies. These are companies that want to have specific features implemented in OpenCV, and it benefits the library, but they also benefits the company. So the fee starts at $50K per year. These companies, in addition to the $50K, they also provide developers who work on the features that they are interested in. OpenCV provides some support for them so that these features can be quickly implemented in the OpenCV library. And right now, the partners are CADAS and Orbec. Licensing partnership, OpenCV is funded by, the OpenCV name is used by companies to produce different services. For example, OpenCV.ai licenses the OpenCV name for consulting services. So if you're interested in any consulting work for computer vision and AI related, please use OpenCV.ai, because part of that revenue gets kicked back into OpenCV.org. Similarly, OpenCV University the name is used by Big Vision to create OpenCV courses. And again, part of the revenue gets kicked back into the OpenCV.org. The latest partner in this is OpenCV Face Recognition. It's a company called 7sense, which has the commercial face recognition engine, and it is one of the top 10 face recognition engines in the world. And they basically
based on the NIST ranking.
Based on the NIST ranking, that's right. And they use OpenCV face recognition. They use the name, and they are basically, again, part of the revenue gets kicked back in. Again, we also make a small amount of money from OpenCV AI competitions. Initially, we did not make, and finally,
not really this year.
Not really this year, but sometimes, when there is large funding from companies, the biggest we have ever made from these competitions is, I think, 75K. This was when Intel, actually it was 75K when Intel funded one of our competitions. Yeah. We have also done very large competitions where we gave away 400K in prizes, and that was funded by Microsoft Azure and Intel, right?
Yeah, so big shout out at Intel. We haven't given a shout out to Kevin and Stephanie and Wei, and everybody at Intel has been so good. Yeah. If you get invited to an Intel party at one of these conferences, you ought to go, because at some point in the recent past, they became good.
Right. So, okay. This we have already covered. So, okay, I don't have slides for the team, but let's see if we have. Okay, I unfortunately do not have the slides for the team, but I can just talk about it. So OpenCV is a very distributed, development environment. We have a team in OpenCV.ai. Basically, the money that they are supposed to give us, we ask them to give developers instead, because this has been a team which has been around for the longest time, right? The developers in that group were initially OpenCV developers. Some of them have been working with OpenCV for 10 years or more. So, and this group is located in Cyprus. And that's why, I mentioned Turkey, because we have another group in China, which is OpenCV China. And OpenCV China also maintains our development partnership with Kadas and Orbeck. So that's OpenCV China. We also have OpenCV, Google Summer of Code, where we have a group of mentors who help us. They don't charge us anything, but they help mentor the interns who we get through Google Summer of Code. So that's another group which helps us, implement features in OpenCV. So to summarize, right, the group in Cyprus, the group in OpenCV China, they are the main, static developers. We used to have a group at OpenCV Intel in Russia. And because of the conflict there, that group, we do not have that group anymore. So we do not have about 5 developers who used to work on OpenCV from Intel.
This was a very big loss, and kind of all at once, and unexpected. And I think a lot of people don't, we don't talk a lot about it because we don't want to seem like we're whining about it, right? But this was a very big change that happened, out of nowhere for us, like it did for a lot of people. But go on, Satya.
Yeah. Intel still supports us in many different ways. So, but we lost the team which had a deep expertise in OpenCV, right? So that was a setback. But right now, the idea is that we need at least some more developers who can work on who can have very broad experience in OpenCV, very broad expertise in different parts of OpenCV. And those who—
It's broad but specific.
Broad but very deep also, right? So that they can basically, we are looking for people who can develop the expertise to be pull request masters, right? They can talk to a very small team of people and decide whether a pull request should be accepted or not. And this may look like a small thing, but it is actually a very important role because it requires expertise in many different domains, right?
Yes, not just expertise, but a certain temperament as well.
Yes.
Kat could talk about that. It's on these open source projects, it is very hard to be the public face of a project when you're the person that, even if it isn't your decision, your name is on the GitHub rejection thing. Like it can be very difficult. People can come at you sometimes, and so it takes not just expertise and knowledge, but also a certain temperament.
Right. So yeah, that's the development team distribution, and we also have contributions from all around the world, people who contribute code and their services. But as far as regular development is concerned for the OpenCV library, this is that's what it is.
I'm going to have to jump off, but before I go, I just wanted to encourage everybody who's tuned in to participate in this crowdfunding campaign. Obviously, we backed OpenCV as a bronze member, but myself personally, I backed the campaign this morning. I think if you think about the value that you've gotten from OpenCV throughout your careers, it makes a lot of sense for you to do that. So thank you to Phil, Satya, Gary for hosting me. Good to see you, Kat.
Yeah,
thank you so much.
Yeah, please support OpenCV.
Yeah, thanks, Adam.
Yep.
Fuck swords.
Bye.
I'm in the same boat. It's getting to be lunchtime, but I
right.
also made sure to contribute this morning. I think it's incredibly important. I know everyone gets solicitations for funding all the time, but especially the software engineers, the working software engineers out there, we are in a very privileged position, and we need to make sure we take care of everyone who's contributing to the software that we make. So please take a moment and make a contribution. And with that,
That's so kind of you, Kat. Thank you.
I will go eat a taco.
All right.
Have a good one, everyone.
Thank you.
Gary Bradsky, thank you so much for joining us. Final thoughts, Gary?
We're just looking forward to the future, and hopefully this will push us past this milestone we had been working for a while to get out 5.0. I think it'll set us on a new level, and contribute.
Thanks.
I just saw one of your kids in the background there.
Yeah.
It was bound to happen. It was bound to happen. Thanks so much, Gary. We really do appreciate it. Your time's a lot more than mine. I know that. Satya, I think we're about time to wrap it up. Take us home.
Well, as I said, the thing that I mentioned in the video, that the future of open source computer vision and AI is in your hands. So don't drop it. We really need your support. It will help grow the library, right? The library is always going to be open source, but it's not that easy, right? It is not that easy because think about how OpenAI transformed, right? They went from being completely open source and everything to being closed source, right? And part of it was funding. It was not easy to fund that initiative. And we don't want that kind of thing to happen to OpenCV. We want it to be free and open source for commercial use. But, there is always this but. It will always be open source, but we cannot guarantee that it will be free for commercial use if the fundraising doesn't go well, right? So that's something that everybody should consider, right? And from a developers, right, we have 1 million developers who use OpenCV. If everybody gives $20, we'll be at 20 million, right? And here we are struggling to get to 20,000, right? So
we just passed 15K. Thanks so much. Everybody who was on the show today, I think, donated at least $200. So thanks so much, everybody.
Thank you so much. Thank you.
All right. Take care of yourselves out there, folks. Take care of somebody else if you can. It is a hard world out there. We will be back next week, next Thursday, with a new guest with OpenCV Live, 9 a.m. I will see you soon, Mamacita. Adios, folks.
All right. Bye.